Hello. It's fixed, I think. Hey. Yeah, it's OBS randomly does that. I don't know why. It's not always OBS's fault, but this time it was. I'll have to add my fucking tasks again. Okay. So, wait, this isn't supposed to be in the directional lighting pass. But it could be. But no, probably shouldn't be. But I'm going to do it for now. Do this. It has to have its own pass, which is kind of annoying and complicated to set up at times, so it'll work exactly the same way either way. Okay. Calculate fog. This actually still does need to be a 2-pass. Let me add task add. Optimize 2-pass so it only renders within the bounds. Maximum bounds of all the meshes. Okay. I have a camera position. I think I do. I'll just say const vector camera. So here's what has to happen. The best way to do this, actually not totally sure. The problem is I have to like do an iterative raycast thing, which is fine. But I think I have to do it with a set number of samples, which is not fine. I'll do it first. We'll see how it looks. Do 10, which is probably way too many. Okay. So like 3 direction, let's normalize camera minus position. So we're going from the position of the sample. Oh my god, my puppy's just staring at me. Stop. Go do something else, okay? God. Oh, he's very annoying when I work. I usually lock him out of my room, but he wanted to come in today. Now that he's in here, he actually hasn't stopped staring at me for like 20 minutes. Okay, now he finally just did, thank God. Okay, so... No. He's actually too needy. It's a problem. So we'll go in this direction. This is to the camera. I know this is not gonna work. Sample step is direction times, I'm gonna say like... We'll try 0.2 for now. So it's gonna go 20... What? It's gonna go 2. 2 is not enough. We'll try 0.5. They are... Mine don't leave me a piece for nothing. And they are cats, so I know I'm probably doing something right, I think. Yeah, well, I wish he would leave me more alone than he does. So, sample position. Or let's call it sample is position plus sample step times I. And I think you have to say, isn't this how you do it? Float I? I don't think you're allowed to multiply a vec3 by an integer. Fog is a texture. Oh. Wait. So you have your uniform sampler 3D, UFOG, SDF, and then uniform vec3, UFOG min, and max. I didn't add these yet. So fog min. So when I calculate this, okay. Fog SDF data. So what has to happen? This might be real. I do have to have a struct. Okay. Fog SDF data. That's an image. There is, I'm just going to give it an ABB. It's kind of all I need. So I have my image, save the image. I realize also this doesn't work because I don't remember why it doesn't work. Oh. It's okay. Because it's serializing the image. If I were to save it as a PNG and reload it, it doesn't allow that because it doesn't know how many dimensions the depth is. But if I save it as if I serialize an image, just straight up serialize an image, it is fine. So remove this. Okay. Data, log SDF. ABB. When you create the SDF image in my SDF helper thing somewhere, where is it? Huh? I didn't do that much since I did this. ABB. ABB, comma. Fog SDF ABB. Because you can only serialize one thing, so this is what you do. There we go. Catch up. Can you imagine I won't be able to watch much further because I actually need to hit the bar and live life a bit. Dang. See you, man. Have a good day. So this is fog STF ABB min. max. So there's my AABB data. That's unfortunately getting passed into here every frame, but it doesn't really matter because it's very fast. Okay, now we're calculating this. So here's why I was stuck. You fog SDF, and this is your sample position, but actually, you have to put this in the space of your SDF texture, so yeah. Okay, so this is fine. So you say sample is sample minus ufog min? Is that what I called it? Yes. Over ufog max minus ufog min. That should do it. And no clamp should be necessary because it already gets clamped. So we'll say move it into texture coordinates .r. Okay, so we want actually like the depth inside the fog. And so the way I did it was maybe I should have done it more precisely, but it's basically, it's a single byte and half of a byte value will equal 0. Anything below that is -1, anything above that is 1. So you get this out and you say fog is basically, let's see, is this right? Yes. So now this red value goes from 0, -1 to 1. So what I actually want to do at the moment is I just want to straight up draw when you're inside fog. Just totally opaque. So if there is any sample inside fog, okay, so I'll do this. Fog strength plus equals the maximum of negative fog and 0. So this will convert this. If you're inside fog, it'll be between 0 and 1 basically. And if you're outside fog, it's negative, and then you get the maximum. So it's only going to add values if you're inside fog. And this fog length I don't actually really care about as far as I know. So that's it for now. Okay. Fog strength is calculate fog of the world position and camera, which is something. V camera. Hopefully this is not in view space. Let's see. No, it's not. So if fog is greater than 0, color is, I'm just gonna add something like, move it towards white. Add half the way towards white. So we'll see what this looks like now. Min is not, it's lower and upper. Turn data, incompatible structs 1 in image 3. Oh, that's just because I didn't change this. This actually wants back out fog SDF data. Now, texture 3 procedure call did not match any possible overloads. What the fuck? This I didn't expect. Texture 45. So it takes an image 3, and then a texture wrap 3, and then an interp. which is, that's just wrong. Okay. This had to have gotten used. I guess it broke at some point recently. Interesting. Found smallest distance. Okay, so it's still printing a bunch of stuff. I should make it not do that. So there we go. Here's my fog. Except... yeah, so this is the problem with doing it this way. With the step function thing. I might have to change this right now. You can see if you look like here, you can see it's actually, though, you can see some of the edge of it. That's actually not that inaccurate either. So that is the fog. Before I really continue, let me remove the print statement from here. Not this one, but this one. Okay, so yeah, doing this in any other way might be hard. I think then what I need to do is actually do it correct, which I'll need to set up a second pass. Like you can't, I don't think you can have a for loop. Yeah, and I don't want to do a ton of looping anyways. So the problem right now is you take the position that of the actual geometry you're starting from, and then you're like, what's it called? Whatever. You're iteratively stepping back towards the camera only up to 0.5 times 10. So a total distance of 5 away from the geometry. And so if you're starting on something way off in the distance, this doesn't get you very far. So the correct thing to do, I mean, you definitely don't want to step through everything. The correct thing to do is render geometry to optimize the fog. I guess, unfortunately, I have to do that. Yeah. Okay, so time to make this a second pass, I guess. Or not. The other thing I could do is limit your steps to the actual texture. I don't think that's what I want to do. Okay, time to do it this way. Let's just go make a different pass. Deferred manager. This is how it should work anyways, because the fog should be rendered after all of the opaque stuff. Yeah. I want to look at this real quick. When it's rendering the transparent things, so it renders transparent depth. Transparent depth renders using the transparent pass. Okay, so it should render right after transparent depth. I don't know what to do about transparent. The things that are legitimately transparent are like some priest particles, the priest bubble, water. So this map doesn't have water, so I guess that doesn't matter, but it's still worth considering. Yeah, and it probably would not just get rendered on top of the fog. So I do think the fog probably gets rendered after all this transparent stuff. Yeah, especially because the fog, it has to write into the depth buffer. It's like required for this optimization purpose. Render scene gameplay fog. So actually, maybe I don't need a new pass. Do I? Kinda, yeah, I guess I do. A new pass is just like a way to structure my call, is all. But this makes it easy because... well, no, it doesn't. Alright. Maybe if I can render into the transparent pass, if I can bind this... okay, maybe this does make it easy. Let's see. So in the deferred manager, I have my transparent pass. I just need to write to this exact same stuff. Light diffuse texture and depth texture. And yeah. This is okay. So first I can bind the transparent pass. No, I can do this differently, I think. Probably. So I only need to read out of the depth texture. Okay, this is kind of weird. So what's gonna happen is I have a fog pass, and it is drawable, and so I'll call it a fog shader or something. It is one. This means it has depth. This means it's drawable. And it has these same two things. Think. That's all I do. So what makes it weird is that this it writes into the depth texture in one pass, and then it reads out of the depth texture in another pass. But the other pass that reads out of it is going to have the depth writing disabled, so I think technically that's allowed. You're allowed to do this, probably. And this you actually don't need, right? You do. You do for the second pass. All right. Okay, so let's get started with this then. This is probably all I have to do. It doesn't even allocate anything, so very good, actually. Set that, okay. So there's going to be two methods here. Render scene gameplay fog depth, render scene gameplay fog. I guess. You are depth testing. Only render if you're in gameplay. And I also have to enable depth right, I think. Yeah, like I do here. Set depth right scope. Bind fog, you do clear it. No, you don't. Do not clear it. Okay, and then, because this is using the same, what you're clearing is the textures. This is using the same textures as the transparent pass, so I don't want to clear those. I'm just writing on top of it. You are blending. I'll call this depth, first of all. And then I'll do this in the call. So that's render scene fog depth. This is render scene fog. Now you are not depth writing, but you are also not depth testing, actually. Blend is yes, you are blending. Okay. And so what happens here, you set scope counterclockwise, set, what's it called? This, false. So we're rendering back faces and then set depth, func, scope, radar. I hope I'm doing this right. I mean, if I'm not, it's just not going to compile, so it's fine. So basically, I need to write I need to overwrite the depth buffer to only... Oh, wait. Yeah, this is still okay. Well, maybe not. How the fuck do I do this? So what has to happen is... I'll write notes. You have to render clockwise winded faces that are maximum distance from the camera without writing over depth values that are closer to the camera. So I don't think this is possible. And actually, I don't even think you have to do this. Maybe. No, you probably do. You do. Fuck. If I were to render each fog geometry independently... Yeah, I can't do that either. The purpose of the SDF was to solve this. I could do this with a stencil buffer, maybe. That's a 3-pass solution. It doesn't really matter though, but... I'll just leave it like this. This will technically work. It's just probably way more depth than I need. Yeah, so this would work in conjunction with the SDF. So what I'm specifically thinking about is when you have two convex shapes that overlap each other in the camera direction, that would cause problems in this situation. I have two mountain blends. Okay, this one. Ground fog. So I have to export all of this. Actually, I need this now. So if I look in 3D view, for example, these overlap each other inside, right? These ones, so that's kind of a problem. So that's what I'm trying to solve. And then also, this, if you draw a line right where my cursor is, it's going through this. There's it enters through here, exits, and then enters again. So that's a problem as well. So those two things are what have to be solved for. And so the solution I'm going to go for now, and I think I can improve it later, is I'm going to render everything, all of these shapes into the depth buffer, drawing the furthest back first. And so it would be like this pixel way over here. And then I'll render the near faces. But yeah, wait, that won't work either. Okay, so it is gonna have to be, because the problem is that would work in terms of getting me the entire volume I have to sample in the SDF texture. And the purpose of the SDF texture is that it solves this type of overlap. So this type of overlap would be satisfied by the SDF. It's like pre-calculated. But when I do it this way, I also need to know the nearness to the ground, right? So I need to know, for example, when I'm sampling that point, that the ground is like 0.5 into this fog. So I think the way to do this is use a stencil buffer, which I've not done yet in my graphics engine. So this will be a new thing I'm setting up. I will use a stencil buffer and I will render, how the fuck do I do this? Only, will this work? Let's think. Only the front faced winding geometry. Only front face winding geometry. And then I'll render it nearest to the camera. So can I like invert this or something? I want to get an idea of what's going to happen here. Let's invert like these two alone are fine. What the, how did that guy get selected? Okay. Here's what would be happening. So this is what gets drawn into the stencil buffer. So this is only the stencil buffer, not the depth buffer. So this is just marking like, can I hide the rest of this? I can't really, damn it. Well, I can select this and like, it's not exactly what I wanted to do. What is it? Alt H, Shift A, Control H. Damn it. Okay. So my concern here is this part. So I'm drawing into the stencil buffer, and then I'm gonna take the fog and then draw the farthest away back face that is marked by the stencil buffer. This would actually work, I think. So in that case, the farthest away back face marked by the stencil buffer would be this. And then when you get to a part that overlaps with the other fog, it would be back there. So that would allow me to sample actually through the SDF texture from back to front and get everything. So technically this solution will work, I think. And I want to try to add back these two center guys, if I can find them, to help me visualize what's happening there. Where the fuck are they? Do they not exist at all? What? Oh, it's there. Oh. Wait, is that a problem then? That might be a problem. Okay, so this is all part of the same convex mesh, right? So if I'm rendering, if I'm rendering the nearest that is a problem. If I render the nearest back face, or really front face in this situation, this would get marked to this section right here, and then the mark section is going to go render the farthest away front face, which in that case would be way back here. So that, like, this guy, that would not work. Interesting. How do you solve this problem? Like, technically this is easily brute forceable if I actually just sample through the whole SDF. I'm kind of wondering if I should do that. Doesn't seem like I should. That is kind of the purpose of the SDF though. It just lets you sample through the whole thing. I don't know if there's a more optimal way to do this with like fancy OpenGL trickery. If though, and yeah, I can't just render the nearest front face, because then this part right here be very transparent, but back here is not supposed to be transparent, and so it would get overwritten by this. So it's almost like I need 2 depth buffers, which is kind of not reasonable at all. I need to render, of this geometry in particular, I need to render the nearest, or the farthest away shape without going past the depth buffer. That I actually think is possible. I don't remember how. In OpenGL, I'm trying ChatGPT. How can I render? There's like a, it might be like an OpenGL 4.4 feature, which in that case I can't really do it. Or I can't sample from the depth buffer while writing to it. Okay, how can I render an object with greater than depth testing, or how would I even word this? With greater than depth testing on that single object while respecting less than depth testing for the overall depth buffer. This is not what I need. I want to only render this mesh in front of my scene, but for this specific mesh, I want to render the furthest back parts of the mesh over the nearest parts, while still respecting my scene. Enable depth mask to read only. This will ensure that rendering the special mesh doesn't update the depth buffer, which preserves the depth values from the rest of your scene. That's not right either. I'm not sure if it's possible. Okay, let me just think about it another minute. Like, I'm putting in all this effort just to optimize it. It would be very easy if I do like 100 samples per pixel. I'm guessing is kind of just what most games do. Or probably more or less most games don't have fog hanging off of the wall. Like if I want fog only on top of a solid surface, that's actually very easy. Where'd that go? I could do this with a depth mask, taking into consideration this might work. If I take into consideration my actual scene AABB, I could render the farthest. I could render. I could do a pass over my scene position, my scene depth, and just mark everything in the scene that is inside the AABB. And then I can render only outside of that mask. Yeah, and so that, and I can do that same thing. So I flip the normals. That would actually probably work. So flip the normals, and then I only render outside that mask, so that would remove this part that overlaps this guy, overlaps back here. And it would also remove this. What would that do? So it would sample from here then at that point, which is fine. Oh, it would also sample from here. If that was inside the fog, which it's not, but theoretically could be. It's not a great solution. Okay, that's not that different from just sampling. So I'm actually just going to sample. So this does nothing. Damn. If I'm just, okay, we will do it in this spot though. Let's try it out. I'm just going to sample through the AABB. It's fine, I guess. Yeah, I guess. So this doesn't actually have to draw anything. This is find, write, and then draw block pass. Really, this only happens if you're in mountain map. Should be in its own pass. Now it is. Do not yet have a fog shader. What would be the most simple shader for this, I wonder? Maybe directional light shader, actually. It's not simple at all, but maybe it's not. This guy's pretty simple. So the out of this is only this. The input is U depth, and that's it. Also need U inverse view. View projection, so I guess it should go up first. Take this method, and this goes here now. That's, wait, am I doing this all in the edge shader? No, only this one I messed up. Okay, good. Fog shader. You go here. I take this, and this. Actually then, Doing this in the shader might be kind of hard. We'll see. Is it only additive? It might only be additive. Or actually, no, it's not that hard because, yeah, I don't have to read the previous colors below it, I don't think. I'm just writing fog, which is just opaque stuff. Okay. This is okay. I also need V camera. I can just take this.
Work.
Hey, thanks for the follow. Toki stuff. The sample depth. Most of this stuff I just need from my directional lighting shader. U depth, I have that. The V chord, I have that. And V inverse V, V inverse projection. Okay. Almost ready to run this. Initialize this, which this, I guess, doesn't need lighting information yet, so I'll leave it as it is. Where is this guy set up after Fireball Hemisphere Shader? Alright, it's initialized. Can I just run it? This isn't a real thing. So that shouldn't have been there. And true depth test. True. Yeah. Okay, I think if I run it and it's correct, it's gonna look the same as before, which is not correct, but now it's in its own little pass, I can improve it. Unify variable calculate fog. That's in directional light, I just didn't remove it. Whoops. Is that here? Yes. There's no color. Okay. It's fine. Technically, it's a gradient now, not a solid opaque, but that's fine. Ufog min, ufog max. Yeah, I didn't do that. Whoops. And I didn't give it. I did give it the SDF. Okay. I just have to stick this here. I wonder if this is actually how you're supposed to implement fog. Construct. Okay, and I need reconstruct position as a shader dependency. It gives me access to that method. Compatible type for parameter 2. What? V camera, that's a map for. It's supposed to be Vec 3. For expansion with a ton of vertices. I have to remove that real quick. Before I reveal if it worked or not, which I still don't know. Okay, that's the only one. Let's see. Okay, there's no fog at all. Where's the fog? If it's a mountain map, do this, set blend to true, set depth test to true, bind right the fog pass, give it the uniforms it needs, which I think this already has. Those are all correct. This looks correct. In the deferred manager, this takes a fog shader. This has a U depth, which is a depth texture, which actually this does need. Does it? Yeah, because I have to read the depth to calculate the position, and then it also Actually, it doesn't have to have it here though. Having it here implies you're writing into the depth, or at least drawing some geometry with a depth test. There is no such thing as that happening, so that's part of the problem. That's probably also why it doesn't work, because depth test has to be false. Okay, so when I initialize this, this means no depth buffer. Okay, now I just give it udepth and no depth test. Let's try it again. I bet that'll fix it. It was probably failing the depth test somehow. Maybe. Okay, that was not the problem. Why? Can I just draw in fog pass? Let's just see if it works at all. This is the Vec 4 of 1.0. It should just, the entire screen should be white. Oh, wait, I think I might know another problem. Okay, the entire screen is white, but I think I have to be the one to give it view and projection. Yeah. I feel like maybe it should be automatic though, to be honest, but okay, now that it has an actual view and projection, maybe I can make it not white and try again. Okay, and yeah, it is gradiented. It's not fog yet, but there's stuff happening. So, oh, you can see there is a little bit of edge fog. Yeah, if I go really far away, actually it doesn't affect it, but yeah, see, it can only go nearby. Like it can only sample back from its position it's finding like 5 meters, which is not good. So that's what I need to fix. Okay, this is maybe hard to fix. So, because if you move around and it continually changes its accuracy of the sample, then if you move around and it continually changes the accuracy of its sample, the fog is going to look like inconsistent. Hey, thanks for the follow. So I'm going to try it anyways and see. I want to be like, that's the most obvious solution. I want to see if it actually looks inconsistent. And so the first step would be clamping this position to the bounding box of the fog, because there's no reason to sample outside of it. Yeah. Okay. That's actually... Is that hard to do? You're my Nolacor's recommendation. Nice. Where did he recommend this? How's it going, man? Nolagor is working hard. How do I clamp this to the bounding box? So... I'm pretty sure there is a very simple way to do it. But... yeah, I think the correct thing is I think I just find all the intersections on planes, which is not that hard to do, which is because it's this. Optimized version when you don't care about unit vectors. Wait, when you don't care about unit vectors. Okay. So this gives you back the actual intersection, and t is the distance from your camera position. Yeah, actually it is. Okay, so this is what I need. I'll just get back t then. Plane intersection. So I'll give it const vec 3 p, const vec 3 dir. In another streamer server. The project looks like incredible though, so I'm definitely gonna hang out every once in a while. Thanks, man. Nice. Another is active, man. So this will be. It's not so simple, right? This is ray P, ray position. This is array dir. This is okay, this is actually not that simple. Plain P, plain dir. Make it all GLSL like. So I also need plain D, which is like I don't have. I can make that. I'm gonna try to optimize this as I write it. So to get plain D is just the normal dot product with the plain position. That's it. Okay. Normal. So actually, for all of these planes, the D is 0. Wait, what? Really? No, that's not right. No. Because effectively the plane position is a vector from 0, 0, 0 to the plane. Okay, that makes sense. So I'll just say D is dot product plane. Okay. Plane D. We're doing math right now. Math is almost over though. Don't worry. Plane dir. This is plane D. Plane N. What the fuck is that? Okay. Plane does not actually have a position. Plane has a normal and a D. So I guess you can derive position from the D. So float plane. So that plane normal is actually plane dir. And then ray P. Plane dir. Ray dir. Alright. That's what I want to return. Cool. Uses all this stuff. Let's just return this. This is the plane intersection. This is the progress. T is the progress from ray P to the intersection. Okay. So I'll have another method. Vec3 get, how do I word this? Clamp to AABB. Min, I guess lower on spec 3 because you can't say min and max. And then conspec 3 origin, conspec 3. I don't actually know what happens, come to think of it, when like when you're casting your distance ray, your depth ray out towards maybe something close to infinity, I don't know what this function actually returns because it's reconstructing it from the depth. Maybe it's fine. We'll see. Okay, so I have to do this. What would this be called? Bottom T equals something. Top T. This feels like a lot of math for what I'm trying to do, like in a bad way. Forward, backward, or words? Forwards, backward. It's fine, I guess. Yeah, see, this feels like a lot of shit to do. I don't know. But it would be... So first, you would also say float point T. So you have to get the point progress in that direction. And so also first, you have to say fucking point dir. Normalize point minus origin. That's the direction to the point. This is a lot of math. Okay, now you're getting the basically T, the progress to the point based on this direction. So how many directions it is to get to the point from the origin, which is the dot product of... How does this work? I think it's really simple. It's the same as project vector, project direction ish. It's this. Okay, I think it is this. Think. Something like this, right? So it'd be point minus origin and then pointer. Wait, but this is also, this can be simplified. So this is the vector between the point and the origin, and I want the point t, and this is a normalized unit vector, so actually this is just the length of this vector. That's the t. Okay. Ooh, complicated. So now we get the bottom t. So we do a plane intersection of the ray p is origin, ray dir is point dir, ray p is u fog min. I have lots of messages. What's happening? Okay, so this is the point on the plane, the minimum bounds, and then the plane direction for this guy is straight up because it's the bottom. So this is how all of them work. This guy is the maximum bounds. Left. Uh-oh. It doesn't, I think it doesn't really matter. So left, okay, I should call it like, this will be, this is a better naming probably. Maybe. Min xt, max xt, min zt, max zt. So then this would be -1 and it'd be min. Just swap these around then. Be a +1 and it'd be max, and I fucked up. Min, max. Right? If it's minimum x, it's going in the positive x direction. Yeah, that's right. Woo. This is min, so again, min. And last one. This is so much math. So it's the 4K plus in the source control tab. Wait, what? You can view the stream in 4K plus. So what is an AABB access volume? Yeah, it is. Yeah, AABB is just a cube that wraps an object. So in my case, I generated yesterday. I did this on stream. I generated this PNG. Where the fuck is the PNG? Wait, why does the PNG not exist? Where did the PNG go? Oh, it must be here. Wait, what? Is it? Here it is. Yesterday, so this is the SCF of where the fog's supposed to be. So this is actually like a slice of the map going this way. I can hide this stuff. It's a slice of the fog. Also, I should invert this back. Going this way, it's like slice 1, slice 2, slice 3. So it's layers of it. And so the AABB defines the bounds of this image is what's happening. No 4K icon on the sidebar. What? Am I missing it? It's on the sidebar? Oh, this? Oh. Yeah, that's probably nothing. It's definitely not actually 4K. It's there's probably one thing that's not supposed to be source controlled that somehow accidentally got source controlled, and it added like 5,000, 8,000 something files accidentally. I never look at that. Relatively all my stuff is pretty up to date that I actually use. Okay, so now this is kind of annoying to do. I think I can do it in a way where I swap memory around instead of having a giant if statement. So I basically have to do like something like 7 factorial comparisons. Factorial, whatever. And this actually, no, this isn't bad because literally all this stuff is based off of the same ray. So the only thing I need is a minimum t value. That's it. So I can say min t is min. It's just, this is going to be giant though. Min max y t min xt max xt. Oh boy, I sure hope this works. Wait. Min x, max x, min y. Okay, so this one, max. Okay, let me undo to this point. There we go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That's right. Okay, so now I can just return origin plus point direction times min t. So this is the closest intersection it's found, except, wait. I think because this is array, it can return a negative number. And that would be, it intersected with the bounding box behind your camera. I think, yeah, it would be. So I want to return a max of this and 0. Okay, cool. I saw a cool video on Quake and BSP. If you have a ton of these box commutations, Quake and BSP. Well, I'm kind of familiar with, I mean, you're talking about binary space partitioning? I don't need anything that complicated. Point direction. Okay, so this is all you do. So now, I'm not sure this is going to work. This is really complicated math. Let's try it out. I'm going to make this not constant and then say position is clamp to AABB. For generic planes, AA helps to simplify it. AA? What is AA? Lower is ufog min, and then ufog max. Origin is camera, point is position. Now it is clamped. AA and AABB axis aligned helps to simplify. Simplify what then? Bound AABB? Generic planes. For generic planes, AA helps to simplify. I'm still not entirely sure what this means. There's my minimum and maximum, my origin, my position I'm sampling, and then what I can say. Now I need the distance of the camera, so I'm going to try to make the sample step something that over 10 will actually go back to the camera. So it's going to be the length of camera minus position over. So there's 10 steps starting at the actual point, right? So I want to do this differently. If there's 10 steps, I want to sample maybe, like, I don't think there's no reason to sample on the surface. So I want to sample halfway off the surface. And I'm actually going to make it 100. And actually that's going to be constant sample count. So this math has to be exactly right. So this would be over float of sample counts. Actually, this is my sample step. So let's think about it in terms of 2 first of all, or something like that. Yeah, you would be stepping halfway through it. So what the thing though is the place you start at has to be plus. All right, actually I could do it here. Position minus equals. Okay, it's position plus equals direction times sample step times 0.5. So you're starting halfway in the middle of a step because you can think of the steps as line segments. Okay, so then you sample twice. You start off a half step and then you go 1 entire more step. This should probably work. So let's put it back at 100 or something. Actually, yeah, I'll do 10 for now and then I'll move it up. And let's try. I don't know. BSPs was too advanced for me back when I was into this at like late teens. Yeah. I remember trying to... Uh-oh. I remember trying to look at the BSP file format for Valve back when I was in high school. My friend and I made a little BSP file renderer in OpenGL. Implicit cast from float to vec3. What? So this is the length of it. So then I have to do direction times. Now I saw the explanation. It felt quite understandable. Fuck. My fog is gone. Uh-oh. Uh-oh. What if I don't do this? I bet if I don't do this, it works. Yeah, technically kinda. Look how bad that is. Is it even supposed to be all the way out there, I wonder? Sometimes it doesn't. This isn't feeling so correct. Oh yeah, see, that's the other problem. It's... Oh, so now is when I need the fog length, by the way. That's probably part of the reason it didn't show up before. All these steps are equal distant. So actually, I don't need to accumulate it. What I need to do is I just need to add to this the length of a step. So actually, I need to multiply this by the length of what you're sampling, which is this. I don't know what you'd call it. I'll just call it length. Can I do that? Ray length makes more sense, I think. Take the strength of your whole thing multiplied by ray length. So it actually doesn't really matter what you multiply it by. In fact, that would be too much. That would be too much. So then I can say a sample length is this over sample count. So then direction times sample length. Okay. And it doesn't matter because these just increase linearly with each other. It's just this is kind of more accurate to what you're actually sampling. Okay. Now when I get close to it, actually, oh yeah, okay, yeah. The opacity doesn't really change, just the accuracy of the SDF texture does. Guess. Let's try 100 samples and see how it goes. So the actual clamp to AABB method is definitely still not right. This is 100 samples, so very accurate. It's not really changing much as I walk around. Hey, working this game solo part of some team. Solo. Solo, except I contract out artists for a lot of the work. That's all I do though. Okay. I wonder how expensive this is. I really don't know. Hi, puppy. I need to add this back though. I have to get this working. Your president definitely looks like something a 5-6 make. Thanks. Appreciate it. Does you fog max? Oh, this is maybe why? Wait. No. It just shouldn't be here. But man, the only thing I can think of, it's choosing the minimum of this guy. Okay, I have a better idea here. What if I say, this is kind of complicated. Here's my plan. This direction is actually going to be this. So now my point T is 1.0. So the T to the point is 1.0. Because you are allowed to have non-normalized things, I think. And so, thanks for the follow. Takap. Now here, this is the problem, by the way. When it's -1, so it's sampling behind you, this goes to be 0. So it's not, that's not, how do I do this then? This isn't what has to happen. I have to discard everything that's less than 0. That's not so easy to do. So it'd be something like, I'm trying to think of a way to do it, hopefully without actually using math. I mean, without actually using an if statement. But I can just optimize it later, I guess. So now if I set it equal to 1, now this isn't needed. Okay. If this goes equal to 1, then it can never be less than this, right? So I guess that's all I have to do. Let me just stick this in all these places. Whoops. What the? I'll do it this way. And then max xt, min yt, max yt. So this method is really fucking stupid now. And now, point direction, this is still actually correct. Well, okay, let's try it out now. Uh-oh. It's totally gone again. Why is this happening? Like, one thing I can think of is maybe I have this backwards, but I don't think so. And I also don't think it matters, actually. Let me check my plane intersection code, like plane stuff. So plane D is position dot normal, which is this. So then you return plane dot D minus the dot product of plane dot N and ray dot P. Plane dot D minus the dot product of plane dot N and ray dot P over plane N. So plane direction, ray direction. Fuck. I'm pretty certain this is right. I wish I could see what these values are. So when I calculate fog, I give it the origin and the point. It gets the ray direction. This all looks right to me. Fuck. Origin plus the point direction, point minus origin times min t. What's the end result geometrically we seek here? Well, when I remove this, clamp to AABB, you can see the fog, right? So here's all the fog. It's just not like, so there's no noise, it looks bad. But the main problem is when I go off the edge like this, see I'm sampling like off into infinity or something. Also the clouds are, that's fine. When I sample off into like infinity, it doesn't, you can't see fog at all. So the clouds actually kind of fix that with 100 samples, but the clouds maybe shouldn't have depth to them. Anyways, the cloud, I shouldn't be reliant on the clouds for this. Like this, for example, you can't see fog, but when I go like this, actually you still kind of can't see fog, but a little bit. But my goal is to clamp, so this is getting some point off in infinity. Wait, that's the problem, I think. My goal is to clamp the point you're getting to the bounding box. Is that the problem? No, that's not the problem, no, I don't think. Can I just, like, return this t value? That's kind of what I want to know. I'm gonna do some dumb shit, maybe. Let's make this, first of all, this. We see fog all the way down, not just inside AABB. Well, we want to see fog inside the AABB, but the point you sample, like the surface you're seeing, the depth of the surface you're seeing, that point should be clamped to being inside the AABB. That's the thing, which it is not. T, return T. I just want to look at this if I can. So I'm returning min t. Now I calculate fog. So, okay. What this will be is the opacity of the fog is directly correlated. That's kind of weird. It's directly correlated with the ratio of how far it is to t. Oh, you know what's interesting? Wait, what the? Oh, okay, that's... Okay, that's fine. I actually want to see the depth instead of this, so... Wait, that does tell me something pretty important, doesn't it? So what I also need to do then is the two directions. This thing probably doesn't matter. Maybe. The two directions, when they're going against each other, the dot product is negative. Okay, so it's probably this that's fucking it all up with my visuals currently. So I actually want to return, to make this more simple for me, this times the length of point direction. So now, and I'll do like divided by 10. Now I'm going to actually, the alpha value is directly corresponding to the distance of the found intersection. So this is, by the way, where the bounding box is. I don't actually know why it's doing this. It makes sense though that this is the wall of the bounding box. The distance to this wall is 0, so that's actually right. It's actually right. And the distance to all these other walls is 0, but I need to go like inside the bounding box. It's really weird that it's like in quadrants. Okay. This is actually right, by the way. Yeah, and so this goes up to infinity. Okay, so the other thing I need to do is, which I was already trying to do this. How the fuck do I do this? When you are sampling against a point. Okay, let's do this here. Min t start at 1.0, since that's actually corresponding to point. And now, I guess I'll just do the dot product here. I don't really like this. If the ray direction and the dot product of ray direction and the plane normal. So in this case, straight up because it's on the bottom. So if they are facing away from each other, I'm writing it in Jai style. So then I can say minty. I don't need this. This is how they all have to work. Let's do all of these. I swear by the end of the day we're gonna have fog. Okay. Might be a better way to do this, I don't know. Let's see, so this should get me my minimum p value, and then I can return this. So hopefully the goal of doing this dot product check is that now when I move outside the bounds, the fog should not move with me. P prime is p minus AABBO. Now clamp the components p to 0, p prime to 0. AABBP, where p is the extent of the vector of the box. Not much plane geometry needed then, I think. Does that really work? Actually, you know what? You remind me though. I think I have an AABB intersection method. I'm just curious to check that. I keep opening the wrong stuff. AABB stuff. Well, I do with array 2. Okay, here's this. Apparently it's not that simple. But they do it per side. Oh, but this is only wait, what? This is kind of the opposite of what I want. We'll basically have a height depth of 3 components, A, B, B. Yeah, so you're probably talking about this. This is doing 3 different components here. I could actually do something like this. It's actually not much less math though, really. I guess this part is less math. Kind of like a one-dimensional dot product. Okay. I might change it to that. It's just a very slight optimization. I would unwrap this though. I wouldn't do a for loop in GLSL probably. Whoops. Undefined variable radar. Pointer? Is that right? Yeah. Oh, Vec. What did I do? Where? 50? The print thing is not very useful for me. If this Vec. Oh, it's meant to be. Wait. This. I think it's a hidden dot product with axis vectors, but simplifies. Yeah, I think that's right. Okay. Let me restart again. And then go straight into the ground. So no matter what, I'm probably through the ground now. Okay, everything is always white. Got it. Oh, and it's because probably of this. Whoops, I meant to say minimum of min t and whatever this comes out to be. Let's try again. So this will only consider 3 vectors. Okay. Actually works. And when I go up, permanently white. Okay, so this works. This works specifically for this though. It's still really not good. I also maybe want to do like divided by 100 so I can just see it better. So when I do divided by 100, I should actually probably be able to see the edge of the bounding box. Or maybe that's not that math's not happening yet. Oh yeah. Oh, that's. I think about that. It's fine. It's fine because of the way the fog works. Like when I go down, yeah, there we go. Oh yeah, so you can see the edge of the bounding box. Nice. Okay. Well, I guess it does work, right? It has to. So I should be able to recalculate the position based on the bounding box. Maybe I fixed it somehow accidentally. Let's try again. Okay, actually, I guess I fixed it at some point. Something I did. Maybe it had to do with that dot product check. Okay, so now we're in this situation again, and so now when I look at this stuff, like at an angle, yeah, I do see fog over the top. Okay. Now, this is decent enough fog. It's not ideal that the fog changes density as I like walk over it. Like when I move away, this part becomes really thick. Which like this is obviously not done at all, but Why would that be? I don't think it should be doing that because of this multiply. I guess though, if I were to remove this and do like over 0.2 or something, it's gonna look way worse, isn't it? 0.2 might also not be correct. Yeah, I mean, the strength is definitely different now. Okay, this is fine. So I think this part is done. If I turn it back down to 10, how bad does it look? Because I want to end up doing a sample count of like 10 if I can. Yeah, it is kind of flickery, especially, yeah. But it might not be that bad because it's going to have noise added to it. So maybe I'll be able to do 10 eventually. But it does still kind of cover the areas I wanted to cover a little bit. Let's change it back to 100 while I'm working on it. So this is done. Now I can add some noise to it. So I'm gonna do, I don't know what to do. I'm gonna try out a 3D noise first. Probably 3D noise is the way to go since this is 3D. Yeah, so that would be in Scene Manager. I already am doing that up here. Blurred noise. Perlin noise blurred. Texture 3. Hey, thanks for the follow. Did you find this stream through Noligor as well? Blurred noise. I will put it... Yeah, I don't know. I like to keep my samplers together, so... I guess. So I'm going to sample this blurred noise to actually get the thickness of the fog, and this guy needs a time. So let me also just throw in here U time. This guy has a time already. You do the same thing. After I get this fog noise working, I'm going to take a short break. Linked in Lingalg. Liked the Nelk, the new algebra, as much as the nice graphics. Thanks. I must have misread that. Not linear algebra, right? What did you mean? So, okay, let's use this noise sample. This is my sample position, and this thing wraps. Actually, it wraps, but there's like an issue right now with texture 3D wrapping. I don't know. I appreciate people doing math. I'll share my SU Lineup. Ah, okay. Really? So this usually I feel like loses me viewers when I do stuff like this. I've learned doing lots of boring math, and basically anything that requires continuous iteration makes viewers go away. Fog density is a texture of U blurred noise. And sample position, except you fmod this. And I'll also say fog density sample is, I want to do it in steps. And I can multiply it by 2, but I can't divide it. If I'm dividing it, I have to do it here. I have to do it inside the fmod. It's also not fmod in GLS, so it's mod. Okay, so it's this R, and so you take this, multiply it here. So you're multiplying the actual density of the fog by the fog density from the random noise sample, and then We'll see what this looks like first of all. Doesn't necessarily look that much better at all. Huh? Maybe. I am passing a new blur noise, right? Yep. I'm on my one. Only thing I can think of is maybe this has to be like... So first let's try like times 10 to make it really noisy. I thought this would just work. Like I didn't think there was any way this doesn't work. I could also, though, allow negative density. Okay, now I kind of see it, yeah. Okay, I kind of see some random density. It's not great. Not great. It's okay, though. And then I want to make it move. So I don't know which direction to make it move in. I'm going to try U time over 1. We'll try this. See what happens. It is moving, but like not correctly. Oh, the other problem why this doesn't look like fog? I'm not doing anything with the nearness to a surface. That's very important. So you can see it's just like clipping through the surface, kind of. Okay. So, I don't know what kind of curve fog is supposed to have. I might just do linear. Turning a clamp of distance over 2. I'll try linear first of all. So when you're at a distance of 0, it's a 0 alpha. Okay. 2 is a lot. Try 1, I guess. I bet it's supposed to be like... Actually, I don't know. I can't imagine how... If it's like a square root, it's going to be too opaque near the surface. If it's like a flipped negative exponent, it's going to be it's going to be like too hard of a cutoff when it reaches 1.0. If it's like a sine curve, then it's just weird and like not natural. So I don't know. Anyways, so the distance to the surface is... What is it? I don't want to really do math each time, so it should be easy to calculate, right? It should be distance to the surface. So surface distance. I'll just call it... I want to call it distance, but that's a function. Am I allowed to do that? Probably. Surface distance is I times sample length. I float I plus 0.5 times sample length. So you start out half a sample length offset, and then, yeah, this is probably right. Oh, hang on, I gotta go for a second. Let's try this real quick. Okay, let's see. Now, near the surface is transparent. That doesn't look very good. Looks okay, though. One more thing before I get some food and stuff. I want to try to move it along the... Actually, my coordinate system's fucked up, so x-axis. Because that's the direction the clouds are moving in. Okay, that's backwards. Let's try one more time. Before I actually look at it, negative. It's gonna take some real effort to make this fog look good, I think. Like this... I mean, it's something. It doesn't look random enough. Yeah, and also, like, it goes way too far down, but I knew that would be a problem. The geometry that represents the fog SDF texture is temporary. Looks pretty bad, if you ask me. Okay, I'll fix it when I come back. So, also, I'm curious. Let me do this real quick. I have a perf tracker thing that I can turn on, and it tanks my FPS by about like 100 out of... I get like 500 FPS. So I'll get like probably 250 with it on. But it'll tell me, I'll be able to compare how long this... Yeah, see, I'm not even at 144. That's really bad. How long this fog thing takes to run. I bet it takes a fucking while. My game crashed? Oh, perf tracker crashed. Interesting. Uh-oh. I don't think I've changed anything to do with perf tracker recently at all. I kind of just want to try again. I don't know why it would work this time though. It could somehow magically have to do with me being on the mountain map. I don't think I've used perf tracker before on the mountain map. Hey, this looks really good over here. Those little tiny edges. Oh, there it goes. Yeah, perf tracker crashed. Let me try I'm curious, if I go here, will perf tracker crash on the grass map? I really want to see how long this takes, because like this fog, this volumetric fog could be taking like 2 entire milliseconds, which is like how long my entire game takes to render. Come on, perf tracker, don't crash. Do not, damn it. Well, that's weird. I am probably not debugging this on stream. 316. Yeah, this is a not simple thing. I thought it was really solid though. It's never had an issue before. Okay, well, perf tracker off. Damn. I will not get to know how long this takes. I guess I could look at it in a render doc real quick. That'll actually tell me. I'm just very curious how long this thing takes. I have to. It is mountain map now. Let's compile it, but not run it. I should just set a render doc to do this for me, right? Whatever. Fine. Okay. Let's take a screenshot. And what happens? So something is drawing fog. This is shadow stuff, blah, blah, blah. Fog. How long do you take? Isn't it? Doesn't have to do with the pipeline state. So what is this guy then? Edge pass. So all this stuff is drawing things again. Can you check how long a specific event took? Enable performance counters. You need to enable and select approximate. Go to window performance counters. Don't really know what this does. Okay, hang on. I'm back. Okay. So whatever. Couldn't figure that out. So we have to make it not look like shit now. I have an idea, by the way. I have some project, if I can remember what it is, maybe by date modified, that I used Jai and I did volumetric clouds that actually look good. I think it was a while ago. Actually, it might have been in Coda Jai that I did it. I think it was even further than this. Maybe this. So I had like a fancy noise texture I used in this thing. It was a fancy 3D noise texture. I think I would want the same type of thing. Okay, it wasn't that far back. Oh, you can't see what I'm doing. I'm going through my files. 1 second. Well, let's see if it's this. Do not think it is, no. Nope. Only other thing is maybe it'd be here. Would it be in shaders? Volumetric cloud shader. This was the volumetric cloud shader. Volumetric clouds. Okay. So I guess I'll do this. I'll try this out. This is just a different type of noise. Let's try it, I guess. Hang on, I'm eating an orange. Okay. So this is technically Perlin Worley. My other one that says Perlin Worley is not. Let me check that it's not. Perlin Worley. Actually, wait, that is. That's exactly the same, isn't it? Yeah. But it's, this one is, oh. This one is a 256 texture only. So it's not. And this one is a 3D texture, but it's 32, 30. It's only one channel, and that's only part of the noise you need. Okay, fine. So I do have to kind of generate it again, or actually, yeah, it would probably not be good to double the size of this guy. What I'll use is this Perlin texture 3. Lava and generic particle system. Generic particle system matters. Well, this is really stupid to do, but oh my god, that's the 2D one. So this, I'm gonna take this Perlin Worley thing and say, I don't even know, 2-channel Perlin Worley texture 3. Okay. I basically want this. So I'll call it not 2-channel, but RG. Let's do that. Perlin Worley RG texture. Okay. RG texture 3, yeah. But I implied it was texture 3 for this other one, right? The SDF, yeah. It's fine. Perlin Worley RG 32, 32, 32. Okay, so now this actually then has to be the same. I'll leave it at 64 for now, but I don't think that's what I want. Okay, I'll leave that comment. And the way you're actually supposed to do this is times the 256, and then minimum of this and 255. And then cast a U8. Okay. Perlin Worley RG 32, 32, 32. So it's actually not that, but yeah, I will. I'll rename it. Load from this image, repeat. Okay. Let's try this out. So now in the scene manager, the blurred noise, Perlin Worley. Fog shader, anything that's you blurred noise is actually you Perlin Worley. Okay, now, whoops. Oh, it didn't work anyways. Pixel format, RG is not a member of pixel format. Yeah, I changed it recently. And that was old code I just copied. So the correct format is RG8, indicating bytes. Given a texture, load texture 3. Create image 3. Save the image 3, load texture 3. Okay. I think this, huh? Cannot open file. If true, do this. Oh, it's assets. Wait, it couldn't possibly have already been done. There's actually no way. So why did it go on? Cannot open file. I am very confused. Oh, because this I renamed? Whoops. I think this takes like a couple minutes to run, by the way. I guess I need to rename this. I started changing my naming convention, so might as well. This has to have its underscore before the 32. And then just do that. Now it matches. All right. I think this takes quite a while to run. How big is a 64, 64, 64 texture compared to, like, let's say a 1K texture? 1024 times 1024. It's a quarter the size. That's not bad. So it's like a 512 texture. Yeah. Not bad. So we're just going to sit here for a minute while this thing runs. And it only has to run once, hopefully. But Perlin Whirly is a type of texture that has much sharper, like, I guess, corners and stuff, and different octaves built into it, I'm pretty sure. And so it's used often for clouds, I'm pretty sure. So the clouds will just come out looking kind of like, I don't know, better. Time to eat my snacks. It is still running, by the way. It's kind of crazy. It takes this long. What is it even doing that's so complicated? Oh. You know what sucks? I'm pretty sure this will work anyways, but this UV offset should have been x plus 0.5 over this number. Oh, like that, see. I really don't want to run it again though. This might be one of the rare cases where it's actually worth multi-threading. Well, we just gotta wait. It's gonna be done when it's done. Oh, there we go. Okay. I want to look at it now. I want to look at it in Photoshop. Okay. So This guy decided, when it saved the image, to save the green channel as alpha. Yep. I'm trying to see if I could use this to make it a 1.0 alpha value, but I don't think so. I think maybe it doesn't matter. Like, I could do this myself. I can work in Photoshop to do this. Oh, it's only gray. Okay, so that's not good. Well, it clearly is alpha as well. I guess yeah, what? Because it's grayscale. Bro. How the fuck would I even do this? Add this mask maybe? Alpha mask? But it's an alpha mask, so if I just go here and make it white, that doesn't help at all, right? No. I was expecting this. I was expecting this to have an alpha channel, which, like, it clearly does. Why can I not see it? I've actually never run into this issue before. I'm very confused. It has an alpha channel. I guess I can make this like black, and then I already copied this. So yeah, let's make this black, I guess. So that'll be my red, I guess. Let's create another image from this, because I just want to look at it. And this one... No, this isn't very helpful, because... Fuck, man. Why did it save it like this? That's so annoying. I could force it to save it a different way, so I could look at it. It doesn't really matter, though, I guess. Presumably... See, I'm not even sure if I save it this way with RG8. Yeah, this probably won't work. Okay, so what I'm going to do is serialize the image in the same way I was doing this. Which sucks. That means it has to run again. So I will make it multi-threaded this time because that took longer than I was expecting. Okay. So it's not if true anymore. You just do it. Well, there's nothing to base the data on, so... Yeah. Okay, we will just do it, yeah. Perlin Worley RG image. Load serialized. Fat image. There's nothing to hash it on. I'm just doing this so I can serialize it. Unfortunately. Fucking sucks. So let's make it multi-threaded, I guess. Kind of sucks to do this also. From 0 to depth. C int thread int and data. I think this is how it works. So it needs the image, which I'll just give it the same name. Give it an image 3-pointer. I think that's all it needs, actually. Hopefully. And then you can pass in an anonymous struct with the pointer to the image. This should be fine. And now I can do this correctly, so plus 0.5. These two guys, plus 0.5. Okay. I think it would have worked either way because it wraps, but this is better. When you actually generate it, which is in this method, yeah. And reuse memory is true. When you actually generate it, then save the image and return this. That's fine, I can just leave the name as it is, whatever. Okay. So now you create your texture 3 from your image that you deserialized. And that might work now. So I want this little temporary bit. I do want to look at it, and now that I'm rewriting this, it's not that hard to look at it. I can just say blah. RGB. So apparently it's gonna think there's an alpha channel basically no matter what, which is like my fault with the library, but there's not a good way to represent that. So now let's go through this. RGA. So I don't want it to be the same name because it's not. Law pixels, so I'll also calculate index. Yeah, this is the index though. This is just directly taken. Fuck. This is R. This is G plus 1. So blah, this guy times 3 plus 0 is R. This guy times 3 plus 1 is G. 3 plus 2 is 255. Okay. That should do it. That should make an RGB, B being alpha, just because apparently that's necessary. So, fucking stupid, it has to happen this way, but let's delete this image. And now it's multi-threaded, it shouldn't take that long. I want to look over it one more time before I run it. Okay, let's try, I guess. Attempt to use a thing from an outer stack frame. Did you though? Oh, I have to say using. Ugh, my computer's freezing. So that's good. Crashed. Jaya serializer. Really? Serializer right. It crashed during serializer write, which came from 414, which was this. Uh-oh. Maybe because I gave it literally nothing. Nothing at all to make a hash from. That's my best guess. Let me look at that real quick. Serialized structure. 63. Get hash from files. So if this defer whatever free, fuck is this? Okay, so this gets filled in by reading files. So this is cache hash, cache size, cache success. So this should just do nothing, and then it should just return 0, 0, true. Yeah, actually, that's what should happen, pretty sure. So if this, that seems reasonable. If this is returning 0, 0, true, the hash is just 0, 0. Okay. So the next thing is 78 is where it says it's crashing, which is serializer right. And then serializer right is 607. Okay. Yeah, I don't really want to fuck with this. I wonder if it ended up saving the picture though. Oh, it did. I can at least look at that. I could actually even load that if I wanted to, but I don't think I do. Okay, so now alpha channel is 1.0. I can look at the difference in Perlin Worley here. So red, this is, I think, octave something Perlin noise. Green, this is like something Worley noise. Yeah. Wait, these look very similar. Okay. If I just make it false, I bet it works. I need to go through and fix my serializer at some point. The reuse memory stuff, which is all I ever use, doesn't work so well. Fuck. Oh. It's because of this. I'm stupid. I'm destroying it. Maybe I can then say defer destroy here. Whoops. I can't even do that. Well, nothing else is getting cleaned up. It's fine. The thing is, when you return this in reuse memory mode, it's just a file. It's just directly pointing back into the file. So if you free the file, you're done. Okay, that seemed to fix it. Okay. There we go. Now, it shouldn't do it again. So if I run it again... Wait, but... Right? If I run it again, it should be fast because it's just deserializing my image. So like, boom, load right now. There we go. Okay, so this clearly doesn't look very good. It's kind of interesting though. It does look a bit foggy. So now I just have to work with this texture. So the first thing I want to do, I'm currently dividing by like 10 or something, multiplying by 10. Let me try to do some other stuff. I guess I'm doing this on stream anyways. This is the kind of stuff that doesn't do well on stream. I'm going to iterate on this shader for like hours. But by the end of it, the fog's going to look good. So okay, the fog is lower resolution now. I'm going to try now sampling into green, which is the other noise function. Okay, interesting. I think it needs to move vertically and not down. Let's see what happens. Looks really bad. Really bad. Oh, look how bad it looks over there in the corner. Interesting. Maybe my sample is just way too much. So the other thing I need to try, I need to look back at my cloud shader from before and see exactly how I was using this texture, because this is like a very specialized texture, right? Okay, it's looking better. Something about it's not good. It's way too fast now, right? Way too fast. Let's try this. Wait, doesn't that speed it up? I think I just sped it up. Yeah, very fast now. Whoops. It would be nice to have shader hot reloading for a time like this. This is actually a complicated shader. You know what I should do too? That was a weird lag. That was physics lag. Okay, it's actually, this doesn't look too bad. It definitely is not the effect I want at all. But it's like, not super ugly. So the reason I think I realize now too, when you look over there in the corner, like way in the corner, you see it's totally solid white. It's because you're viewing it at an angle, so your ray has a much further distance to travel before it actually gets into the, like, hits the surface. So how do you fix that? I don't know if you do, because that's just how fog is. I think what you can do though is you probably want to do some function like this. Probably is like an exponent negative x. So one minus. You probably want to do something like this, which is just kind of like, I guess, a different square root ish. Oh wait. So instead of assigning it back to itself, you would multiply it by this number based on the value. So at 4, it would be 1 though. So am I doing this right then? So no, not doing this right. This is interesting. This is a cool curve. This is probably useful for lots of things. Too bad I'm definitely not remembering this ever. Maybe you could take this and add 1. Whoa, it got to 1 1. Wait, that's such a good curve. Holy fuck. I actually want to remember this curve. This is so good. This is useful. This is definitely useful for so many things, man. Ugh. Okay. It doesn't even go above 1, which is very good. So this is actually kind of what I want, except I want to move it over here. So I gotta take this whole thing now and add one again, except you also add one here. Or is it -1? Wait, why is this not working like I think it should? -1 and then add 1. Okay. So that would just make it this times x plus 1. Okay. I'm surprised I still have viewers. So here's my curve. Okay, so this is the curve that I'm going to multiply my density by. Because it's cumulative density. I think this might work. This looks really fucking good to me. Cool. I really want to remember this. Hang on, give me 1 second here. Okay. It's screenshotted. The curve will remain permanently. So the fog density at the location is based on the entire sample through fog strength. It's like fog raw strength. Raw strength is just this times surface alpha. I don't actually know if times surface alpha is necessary, by the way, but oh well. Okay. Save your total raw strength. So you take this entire thing and then you say like, I want to lessen it by this much. Angle multiplier or something is exponent negative x, which is fog raw strength, times x plus 1. All right. Here's my nice little curve. This is probably, by the way, maybe what the density towards the edge should be. Something to do with this. I don't know what, but it's a good curve. So you take this whole thing and you multiply this whole thing by the angle multiplier. So let's see what happens. What? That's supposed to be that. Actually, no. Okay, let's just try it. Yeah, let's try and see what happens visually. So I want to compare this to over there in the corner. Okay, it seems to lessen it too much. It's like gone in the corner. So exponent negative x times x plus 1. As most... Okay, so what's actually happening then? This will be like a of x. That's what I'm multiplying it by. So you take a of times x. Yeah, so that's not good, right? Maybe I should just put it in a square root function. I'm probably overcomplicating it. Yeah. Let's just try square rooting it. So actually then fog raw strength not necessary, and you just take the fog strength and square root it. So at least this one continually increases. Okay, that I think does look better. Nothing is entirely white. So I've fixed it so that there's no totally white sections. I see the fog kind of rolling. I think I need to get rid of stuff like this on this edge over here. Yeah, I can do that. I already am, actually. So this fog strength is the SDF. Yeah, there's not much else I can do. It's already kind of interpolating it that way. So the other thing I could do, though, if I want it to be softer towards the edges, this value basically goes to 0 at the edges. Right. So I could do... How would I do this? This is the same issue now. I guess it's just a linear fall off again. So I will do a surface nearness alpha. SDF edge alpha is surface nearness alpha of max. It doesn't really have to be max anymore. It's just negative fog. That's it. So at the edge of the SDF, this value is 0. 1.0 into the SDF, this value is 1.0. That's all there is to it. So now I have some linear interpolation for near the surface and a linear interpolation for near the edge of the SDF. Ooh, okay. Let's see how this looks. Oh, it's gone. The fog is gone. Over here, it's not totally gone. Looks really weak and not good, though. Yeah, the other thing I wanted to try, if I unlimit my FPS, okay, I'm getting 150. This is kind of interesting, right? I'm getting 150 FPS. So check this out. Watch. If I go to Scene Manager and I don't do this pass, my FPS goes from 150 to... Let's see... 290. This fog is the most expensive part of my game by far. So one other thing though, I'm doing 100 samples. Let's see how it looks if I actually do 10. I think just literally this will increase the performance by 10 times, which then should be like 240, which is fine, maybe. The fog is going to be optional. Okay, that looks fucking horrible. Oh my god. Wow. It just looks really low resolution, which like surprises me. You know, though, so this is actually, I can make this a lot better while keeping this performance. Because this part, I couldn't do it before where like I sample the furthest part away and then go towards the camera. But what I can do is a pass where I draw the actual overlay of the fog, so the top part. Okay, so kind of try to remember how this looks. And now I'm gonna render into the oh shit, can I do that actually? I'm not sure. So maybe I can't. Because I kind of need 2 points now. I need to know the furthest back point of the fog, and I need to know the top of the... Let me add back on the FPS limiter. I hear my computer going crazy. And then I need the top of the fog, like, convex mesh. Yeah, this is a low quality, man. So I could render this fog as actual, like, cubes that I kind of randomly generate and roll through my scene. And then it doesn't matter if they overlap. And then I could sample the SDF texture through those cubes, and that would increase the resolution. One other thing I could do, I'll try this as well. So when I calculate fog, I have the camera position. I'm pretty sure, although not positive, the camera is way above the fog AABB box, right? So the other thing I could do is also make this not a constant then. And anyways, if it is inside the AABB, it does nothing. This function does nothing. So ufogmin, ufogmax, and then we go backwards. So from the position to the camera. And that will adjust the camera position to be inside, to be on, yeah, inside the bounding box. But that's not technically okay to do. Okay, hang on. No, it is okay to do because this is on a per fragment basis. So this, it retains its direction. Okay, let's try it then. I'm very curious. It does actually, it didn't very much improve the resolution, huh? One other thing I could try to improve the resolution here. If I multiply this by 4, 4, 2, it should just double the resolution, but it should make the fog like smaller, more detailed. Yeah, which doesn't look great, but it's not supposed to look great yet. Okay, it's still, you can definitely see the pixels still though. Not good. I'm not very willing to go above like 10 sample count. So the other thing I can do, well, does this even fix it? This would optimize it. This would help optimize it. So this is starting to look not that bad. All I did was double the sample count. It's probably like 220 FPS. The fog will probably be optional anyways. I think eventually it's gonna look good though. The other thing though I can try is I could actually go into my convex geometry that defines the fog SDF, and I can make a bunch of individual convex shapes. And I could render them all. That's a bunch of draw calls though. I could make a bunch of non-overlapping convex shapes. That would also be kind of hard to do. But if I can do that, The benefit is each guy would have his own AABB defined. Yeah, that just seems like it shouldn't be necessary to me. I kind of really do need somehow like 2 depth buffers, which seems really stupid. How else can I do this? Like, the fact that I can see the pixels over here on this side leads me to believe it's only getting like 1 or 2 samples. And if I go up closer to it, now it's gained resolution. As I back away, it goes to the camera, massively loses resolution. That is only a problem visually on the sides of the surfaces, which actually I want to remove that. So maybe I should ignore that for now. I want to remove them on the sides. Maybe I should ignore it. Okay. So let's just continue trying to make it look better then, actually. So, what the fuck? This is interesting. This, in my previous volumetric cloud stuff, I actually used a while loop. Interesting. Yeah, that's not super reasonable to do, though. That's if you want to step a consistent number of steps per every single thing. Maybe I should... This is also kind of how it should work, right? Maybe I should. Yeah, maybe that's better to do, because what you can do also then is if you're not currently inside... Oh, that's probably way better to do. I didn't think about this. So the fog is kind of usually pretty thick. And so this might look weird on edges, but we'll try this. What you can say is you step like whatever your step distance is, and then if you're not inside fog at the moment, you can actually step maybe like 4 times that distance and continue stepping. Okay. Whoa, inside is true. How do you do this? I don't even, have I ever even typed a bool before? Okay. While you're inside, calculate your UV coordinates. Sample has to be also inside, I guess. This is fine. Okay, I kind of see what's happening. So I need to pre-calculate sample. So if vec3 sample is position, so pre-calculate your sample based on the position. And then this actually happens at the end, right? So sample becomes position, and I, so there's I is now like step count or something, so step count is 0. It could be a float. So nothing. And this is times step count, and we increment step count here. Okay. If you're inside, continue doing this thing, then at the end of the whole loop, increment your step count once, recalculate your sample position, and then recalculate whether or not you're inside. Alright. And then we can do all this stuff. So actually, I don't have to clamp the camera position anymore. So what I do have to do is have a step size, which is not dynamic anymore, so that's good. That might help a lot with various things. Sample length. I'm just gonna guess something. So if it was 20, and it was probably a distance to the camera of like quite a bit, I'll try 0.5. Okay, hang on one second. Okay. Sample length, blah, 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 sample step, position is direction times sample step times 0.5. That's fine. Okay. And so, if you found fog, right? Which I can check raw strength. Dynamic sample step. It's sample step should be replaced. I'm going to comment this out for now. Sample step should be replaced with this multiplication thing. Or rather, I can pre-calculate it. This is fine. So this will be outside sample step is this, I'm going to say times 4, maybe? 4 might be a lot. Outside sample length, I'll just say, yeah, we'll try times 4. That'll be times 2. So maybe this times 4. Now I can use outside sample length. Here's my outside sample step. Okay. So if your raw strength is greater than 0, is that fair? Because, yeah, that's fair, because it has this clamp thing. Okay, if your raw strength is greater than 0, you do this. Otherwise, outside. I'll call it like skip, maybe. So now we're going a much further distance when we haven't found fog. Let's get rid of this also. Probably should have committed what I had. And then you normalize it, and then you check inside. Okay. At the end of the whole process, yeah, I guess you can multiply it by this. Let's try it out. Undefined variable I. Where is that? This surface distance. So that would be step count plus 0.5. Oh, that's not exactly right. Okay, so this isn't how it works anymore for surface distance. Oh, this isn't how it works either. So I do have to continually iterate on this. So I'm gonna have it be a float instead of a vec3. Progress length. this will be this times 0.5. So I do not modify the position. Pretty sure. Position never changes now. This is the starting progress length, so progress length times direction times 0.5. So start off half a sample length towards your goal. Okay. Step count actually also not necessary now. So surface distance is just progress length. I can do that. So if you're outside the thing, progress length plus equals skip sample length. Otherwise, it's plus equals sample length. And then you take this, and no matter what, this happens here. So sample becomes position plus progress length times direction. So I'm moving the sample position towards the camera and then normalize it. I think this might work. And when you're outside, I did it backwards. When you're outside of the fog, you add 0.5 or whatever, or I mean, when you're outside of the fog, which is this, when you're outside the fog, you add 2.0. When you're inside the fog, you add 0.5. So you go further when you're outside the fog. Okay, complicated. This all looks good otherwise. This is not a thing anymore. Well, yes, it kind of is. Yeah, it is. All right, let's try it out. This might make it a lot faster. I'm like skipping a lot when you're not near the fog. Okay. That, well, I need to check the performance of this, but like all the little pixel issues way in the corner over there went away. This looks like the quality of it, it's not stylized at all yet, but the quality of it looks, I'd say, satisfactory. Oh wait, I need to unthrottle the FPS and check. It should be around 250 at least to pass the reasonable performance test. So now it's just within the bounds of this AABB texture thing. So, whoops. 300, what the fuck? It's faster than before. It's faster than when I was doing fixed steps. Interesting. Good. 300 is an okay FPS. What was I getting when I don't do this pass at all? So this is around 300. When I disable the fog pass, how much is this hurting my performance? Actually just about 0 somehow magically. Literally 0. What? Like sometimes this is worse. It goes down. What? Okay, so the fog pass is like incredibly fast somehow. It's interesting. Good to know. I don't know how the fuck that's happening. Anyways. Good. That's really good. I don't know how, but it's really, really good. Okay. I'm just very confused how it's so fast. Anyways, now I make it look better. How do I make it look better? This is doing some tricky things. This is doing a lot of tricky things, and I don't know if I care about any of this. I should look up some fog math, though. Fog math is probably, like, very much figured out. Like, what the fuck is this? Beer's law? Multiple octave scattering? This is from some Twitter post that people can look up if they want, I guess. I mean, I guess I should copy this. I don't know what the fuck this is. Let's try it out. I should make this easier to look at, by the way. Jesus, this is giant. You just say GLSL. Okay, how am I using... So multiple octave scattering sounds important, especially since there's a Twitter link. Get light energy? What the fuck? Get light density? Okay, so this is actually sampling it as well, by the way. So that's basically what I'm returning. Okay. Sample high def cloud. Light step weight. Dimensions, that's fine. This kind of all makes sense. Yeah. Just a different way to do it. So this get light density, which now I'm using here. This is this guy. Fog. What should I call this? Fog density. I'm kind of using that name already, but whatever. So there's lots of other things that have to happen now because I have all these other methods to look at. Multiple octave scattering. Okay, this looks like it just takes light density mu, which this takes also. Oh, I actually totally fucking get what's happening. Oh my god. Wait, do I actually want to do this? Holy shit. I guess it is fast as fuck now, huh? Okay, what's happening is... Oh god, wait, this is maybe really bad to do. Fuck me. For every point inside the cloud that you're sampling, it also steps towards the sun, and it continues stepping towards the sun until it finds no cloud. So it can calculate how much the light penetrates that cloud at that point. It would look really fucking good, but I might actually want this. I might actually want to try it at least. This is becoming kind of an insane thing, I think. I'm gonna do it my own way, though. I kind of want this then. So this, I think this uses the same function. Let me check this guy. When you get light density, you get the sample high def cloud, and then also this samples the high def cloud. Okay. Got it. So I kind of want a function that wraps all of this stuff. This has gotten suddenly just exploded in functions and complexity. So I'd have like a float get fog density with the vec3 position. And this position is going to be assumed to be inside the AABB. And a direction. I don't know if this can be const. Probably it can be. In fact, yes, this one should be const. Okay. So it's basically this function, by the way. That's what I'm kind of replacing here. It could be maybe less accurate, though. Const float step. I guess I'll force you to provide a sample length. It should be like 0.5. So when I'm doing this now, I could just return to keep it the same as it currently is before I make it really complicated. Position, direction, sample length. So position, direction. I need that then, I guess. Direction, sample length. I guess I'll also have that. Boom. That's what it is. And let me be sure this one works now. Skip sample length, the sample length times 4 constant. This is already a thing, I guess. This is fine as well. Yes. Inside fog density sample. It's important they sample the same thing basically, because it would only look right if your light is getting the same data as your screen, you know, fog color. So, all right. Thank God I didn't have to figure this all out myself. I remember I spent like a week doing this, making a good looking cloud just for fun. This was like a year ago. So now I can just reuse it. Finally, it paid off. Who would have thought? I didn't waste my time. Progress length, blah, 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 sample, blah, 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 inside. Okay. Now I can just return this from this guy. Cool. So why did I do this? It has to be used in this function and this function. Get light density, light energy, the fuck, man. Extinction multiplier. I think I just returned this. Get light density. Just returns. Yeah. Very simple. Return get fog density of. I'm wrapping it though, because this one only has a position, and that's fine. Chord. I don't know about having it be chord. I'll have to look at that in a minute. It's not chord, but get the fog density of position. The camera in this case is the sun. So it's the camera is like. Okay, there's no camera. There's a direction. So the direction is the negative sun, which now we need the map part shader dependency. So let's add this map constants, and then we get shadow light forward, and that's negative shadow light forward, and then sample length. I'm gonna make it. To do 1.0. I think it should be 1.0, less resolution than you can actually see. Yeah. Okay, it's probably fine. Okay, then. Oh, you know though. What should actually happen as well? I don't don't know how to do this. I don't think I want to sample my shadow buffer. The shadow buffer is embedding itself to become a permanent part of the game, man. What should actually happen is it should collide with geometry. Which, yeah, the only way to do that... maybe I'll add that in a minute. It's not hard at all to add, so maybe I'll add it in a minute just to test it out. Geometry test. That would be kind of interesting to see. However, yeah, that would probably work. Because if it's in my frustum, it should be in the shadow cascaded map. Okay. Ooh, complicated. What is this? Okay, also, since I did this, this is what's on my mind right now. This fog shader has to have all this stuff to do with map and light, because now it cares about that. So now, for example, this thing is reinitialized here, so is this thing. Okay, that should be it. Let's continue with this then. So yeah, I want the extinction multiplier from here. I don't know what this is. Wow, lots of stuff. Ambient strength, extinction multiplier. I'm gonna... let's see. This can go where it's used though. Which is in two places, unfortunately. Okay. So light density is there. Mu is, I guess, their light density extinction multiplier, powder, and okay, remap. Is remap a real thing, or is that a function that is created here? Okay, it's a function created here. What the fuck is happening? So I have all these functions too, I guess, now. So yeah, I would have actually guessed lerp was a real thing. I guess not. Remap I didn't recognize, though. Phase function. What the fuck? What the fuck? This is the cloud stuff that's going over my head here. It's gonna look interesting, for sure. Pi. Pi is not a thing. Oh my god. That's way too many values. Okay. So remap exists now. Multiple octave scattering. Does this function work now? Phase function does exist now as well. Extinction multiplier exists. Density exists. Beers phase. Attenuation contribution. Scattering octaves. Okay. I kind of get this multiple octave scattering. It's like spreading the light. Okay. Get light energy. Do I really want to copy this though? This seems reasonable. Oh no, this is complicated. I get it. It's the transmittance number continually iterates down as you step. Fuck. And this uses all that other fancy stuff. That is pretty reasonable though, because now you have to grab the lights effect on the pixel in the cloud per step. Okay. That can happen. So the problem with that is basically you're doing the same thing except with extra steps inside of here. So I wanted one thing for all of this. That might not happen now. In fact, like it just can't happen, right? So okay. Basically, this is the fog density. I'm gonna say, what is it called? Get the cloud scattering transmittance. Like I don't even know what that means. To do, I'm not sampling the repeating textures based on dimensions, but I should be. Oh, well I am now. Get fog scattering, I'll just call it. So this is basically the same thing. I also maybe just want to check that it works right now. I've changed a lot of shit. Get fog scattering. All right, let's try it. I think like at the very least it should compile. Whoops. Not that it should compile, but once it compiles, it should work. Okay, so this is good. This looks exactly the same as it did, which is the goal. So now we change this function. And this function becomes more similar to this. So I don't know why this was necessary. That shouldn't, this is just a stupid way to do it. My method does the same thing. The inside check is true, and then it readjusts the inside at the end of the loop. That's just better. So you get the extinction, which is sample high def cloud. Hang on a minute. What? There's no way it does this. This has to be a single sample, right? Okay, thank God. I thought this was another loop, and then it's like a fucking exponentially quadrupled for loop, but it's not. Okay. Whew. So yeah, maybe this function, this does make sense. So when I sample, I should have a function, because now I have these two functions that are like exactly the same. So I should have a sample cloud const vec3 sample. That's all it should care about. Sample cloud density. Maybe get. Wait, what is this then? Get fog density. Oh wait. Fog scattering. Calculate fog. Oh, this shouldn't be. That's why it's the same. This shouldn't be used. What I meant to do was. What? Oh, I just put this here. Okay, that's fine. That's fine. That's fine. I just copied all this stuff and put it there. I forgot. So get fog scattering actually. This is what it should be, I guess. I'm gonna just comment this out for now because it's confusing me. So, the scattering. This has to be up one more. Here, get cloud density. Fog. I keep calling it cloud because it's a cloud shader I'm copying this stuff from. So this is very simple. This has your sample coordinate, and it just does this. Although I cannot do surface nearness. I can do... Can I do surface nearness? No, not really. Yeah, not really. So I think I'm going to get rid of that. Okay, so all this stuff goes to become float raw strength is get fog density of the sample. That's it. And now this guy goes here. Take your sample, your U time, whatever, per and Worley. Fog SDF sample. This can go away. It's not actually necessarily needed, because inherently by stepping and adding things, you're getting this value already. I was just trying to make it more extreme. Oh, I actually just copied the name. Okay, fine. Sample. Okay. So similarly, all this goes away. This is just supposed to be added by raw strength. Raw strength is just used to determine the progress. Okay. Which actually doesn't matter now. So fog strength. So there we go. Now I actually will delete that. And then fog strength. This is fog strength. So same thing, now I can get fog scattering. It has a direction though, so the reason I would want calculate fog is because I don't want to have a direction. And I need to do this clamp. Turn this, so it's kind of a similar concept as, not this. This, I guess, but okay. So it's position, and then direction is vec3 direction is normalized. You're going to your camera. So this is your direction, and your step is 0.5. Geometry test. Shadow map test. That's what that actually is. Okay, so now when I calculate fog, it should go through get fog scattering, which should still, for one more attempt, look exactly the same as what it did before. And then it's going to start changing. Get fog density is no return statement. Sample. Huh? Oh. Where's my fog at? Where's my fog at, man? Fuck. Clamp position to AABB. Am I doing that right? Clamp to AABB. Is the camera the correct thing? Origin is camera. Yes. Okay, so it's clamping position. The direction is normalized. So we're starting at position to the camera, stepping a 0.5. So this function has to be wrong somehow. Actually, I don't see how. Isn't it like exactly the same as this function, by the way? Maybe it's this. Maybe I fucked this up. Sample fog density. Take the sample, mod it. Okay, times 2. This all is fine. That's a fog density sample. You sample your Perlin Worley green. That's fine. Sample your oh, but then it never multiplies this, but it should have been fine either way, by the way. Definitely should have been fine either way. I also want to say fog density plus, this should like never matter. But the thing is, it uses this output to decide when to skip. And so I think it might actually matter. In the case that the fog density is 0, which I think it can be, it would skip, which would make it suddenly randomly, for no reason, inaccurate in the middle of the fog. Okay. But this is not the problem. The problem is that it doesn't work. The camera can be const. I would like to know why it doesn't work. This looks right. Get the fog scattering. Fog strength. It's not ever adding a value. Oh, that's the problem, huh? Total fog. What would I call it? Fog density? Call it fog. So you do this, and then you say fog strength. So I'm pretty sure, by the way, the other one's broken too, because they're the same at the moment. Yes. Fog plus equals fog strength. You do still have to test that, so fog plus equals fog strength and then fog. Square root of fog. Alright, let's try it. Cool. It does look the same though, right? That's what I want. And slightly... Oh, you can really tell that I removed the fucking... the edge softening. That was apparently very important. Alright, let's add that back. I can add it back, it's just... Fuck. The problem with adding it back is that these things happen in two different directions. Okay, but I can make it work. I can actually make it work in both directions. So okay, when you sample the fog scattering, this one's simple. I wish I still had that code. Damn it. Okay, so what did I call it? Surface nearness alpha. It's just literally just basically returns the distance. So surface alpha is surface nearness alpha, and I have to calculate the surface distance. So the surface distance is progress length, because that's what continually increases. Okay, and then edge alpha. So if I'm really doing this correctly, do I actually need this? No. I only need the surface alpha because the edge nearness alpha is taken care of by the SDF. Oh, but I do want more control over it than that. This is true. Okay, so what I would do in that case, since I want more control, I'm in my SDF generator. This has to return a vector 3. And that vector 3 would be the width, height, depth units. Maybe I have to specify it, I don't know. Width, height, depth units. Okay, so I'm gonna have to regenerate the SDF image. That doesn't actually take long at all. In fact, it might be permanently doing it. And it is permanently doing it. Okay, that's fine. Hey, thanks for the follow. Bullseye Pie. Thanks, man. Check out my wishlist Fat Goblins on Steam, everyone that's here. That's the reason I'm streaming. So this is like a SDF unit, which is a vector 3. So this is an SDF unit. SDF unit is SDF unit. Okay. SDF unit. Should I call it a unit? This is fine. So this is the, in terms of SDF sizing, I might actually not be right about this, but it's based on this value for sure. But this value is EFOG SDF EFOG SDF unit. This will be like 2.8, 3.0, 3.2 or something, and those are how many in-game units the SDF considers over, I don't know if it's 0 to 1 SDF value or like 0 to 0.5. I don't know, but it's one of those two, and it doesn't really matter because this is just some value that I want to use to scale my thing. That's all. So that's all I should have to do. Now I have my SDF unit. So the reason I'm doing this is because no volume density. I think you should be forced to pass in a edge distance when you sample fog density. Float edge distance, because this is just like, hey, by the way, you need this, or like surface is, yeah, that's more correct, huh? So this whole thing times, again though, I'll do it here. This has to be plus 0.0012, so if I just multiply these together and add 0.001, it's kind of the same thing. Okay. So does it ever multiply? It just gets the fog by the SDF, but that's not exactly right. I want to control this. And so I'm going to have another method. SDF nearness alpha. Yeah, I think this is the, I think that if I'm remembering correctly, this is probably after I multiply it by 2 minus 1, this value corresponds to that distance of the SDF unit. So how would this work? That's It's a const. I guess this can be const too. I guess everything could be const. Oh well. Distance is what? Distance is. See, I have. It's about the same though, right? Like I have these values for x, y, and z, but they're approximately the same. So I think it'd be in my interest. I want to float, which means I have to kind of do the length of this. So this is like averaging the three together. Isn't it? That's not exactly averaging the three together. I guess I literally want to average the three together. Is there a better way to do it than this? Like, if I dot product with, I don't know, whatever, man. So it's x plus y plus z divided by 3. So this is this really the right way to do it? The SDF, because the SDF represents the actual distance to the thing, and this is representing, yeah, this is probably the right way to do it. The distance, the difference between the length and average is kind of weird. But the actual SDF value should correspond to a length, not a axis aligned length. So that would be this. Okay. I should write that. Is the average of each axis, since conceptually the bit sampling of the SDF is, and yes. I feel like this is a really confusing explanation, but there we go. Okay, so now for my SDF unit, now it's a float. Yay. So back to this function. So I just multiply it, right? That's my distance. And then return kind of the same thing. So this should, yeah, before it was like 3. It's 3, so this is kind of, I guess, increasing the density of the edge by like 3 times is what's happening here. Ooh, okay. Yeah, so the correct thing to do is probably fog is, I think I can pass it in of max, and then it doesn't even have to be this, it's just negative fog. And then actually this is all I do. Oh, times that. Negative fog. And this is SDF nearness alpha. Or another way I could do it, it's fine. I could have a function like SDF to distance, and then I could pass the distance into SDF near surface nearness alpha. Maybe that is just better. I don't know. Fine. Distance. So then you just, this is like so incredibly simple though. I hope this gets optimized away. So you do this and then this. Okay. And this guy is, no, wait, what? This is the important guy. You get multiplied by this, and this stuff gets added by +1. So if this, I guess I can call it SDF alpha maybe. If the SDF alpha ends up being 0, which it can totally be, yeah, then this entire thing will end up being 0, and then it'll skip steps. So that's very, very important. It has to skip steps. All right, Jesus, there's so much stuff happening. So I also need to provide it with the surface distance. That was the next step here. And that for this one is not so easy, but I'm going to skip this one for now. Get fog density. This one is easy. So the fog scattering goes directly off the surface to the camera. And so, yeah. It was actually wrong before. Okay, so it's like this. You pass in progress length is the distance of the surface, right? So it's basically starting off as 0.5-ish. It's starting off of half a step. Okay. So what makes this one complicated is get fog density is used by the light scattering. Yeah. So I'm going to call it get fog light density. And in reality, this is going to be like the only method that uses this. So I don't even know if this should exist. So it has a sample length and then starting surface distance. I'll just call it surface distance. So this is the surface distance when you start. And you just add the progress length into that, actually. So it's not perfect, but it does the same thing. So what will happen is you're sampling the fog light density as you move away from the surface. And you're sampling it for every single step to determine how much of the light that fragment of fog can see. So essentially, the whole concept is as you move away from anything, you're moving away from the surface. That's the general rule of thumb. So, yeah. So you start with this, and so when you do this, you can see how this is used. When you get light density, so float surface distance, this also has a surface distance. So when this gets passed in, get the light energy, also surface distance. And then this is not used. Okay, now we're back at actually making progress. Okay, this is going to be a bit annoying to replicate, isn't it? Make it const. Everything's const. Except not that. Okay, so you have a transmittance, which is 1.0, and a scattering, which is a vec3 0. Scattering is kind of stupid because it's only a vec3, I think, because of the light color, which I guess I do care about, actually. Maybe? I don't know. Maybe. I'll try it. So scattering is a vec3. This is happening here. Scattering. And then transmittance. Is that 1.0? Transmittance. 1.0. So for every step, you calculate the extinction, which is the progress into the cloud. Okay. Which is this. So then, if you have extinction value, basically you do this stuff. Huh. I don't know what the fuck this is doing. Oh, it ends early. If it's totally opaque, if ever the cloud is totally opaque, it ends early. That's interesting. Not a bit too strong of music. Okay, so you have an ambient color, which... Okay, let's start copying this. So this is the extinction, is the strength into the cloud, which I'm not sure if that's the same, if this is actually the same type of value. Like 0 to 1. Like maybe it is. Step weight. Step weight is what? The length. Something that adds up to 1 when it's opaque is what this is, I think. So for me, that's just sample length. Okay, so I do have these constants. So I have like a ambient color and an ambient intensity. So I guess I'll have like a const 3. Ambient is ambient color, ambient intensity, just so this only has to happen once. And there you go, ambient now sunlight. That is the first light color. I guess I'll have shadow light color, which is different than shadow color. So that's what I use. Luminance. So take your fog strength times luminous minus transmittance. That's how much into the fog you are. Okay, that makes sense. So this should be like accumulated. Anything that's a result dot is accumulated, basically. Break out of this. All right. Am I done? Then your cloud is a color. That's weird. Okay, so your scattering result, which this returns an entire thing. I'll have to see how this gets used. So down here then, you have a scattering and a transmittance, and you saturate it. What the fuck? Saturate lots of things. Oh. Okay, sure. I'll take that method. Is that really what saturate means in this context? Just clamp. It's kind of making it additionally confusing by having a method called saturate that does actually fucking nothing. But alright. I didn't write this code. Not really. So this is then what I need to do at the end of my scattering method. So I'll have accumulated scattering, accumulated transmittance, and a cloud color. So I'll have a vec3, constant vec3. Cloud color is something which I think is white, most likely. Or maybe it shouldn't be. It is white for now, at least. Okay. You know, I think one problem is the sun is also technically white, which is not going to look good, but I'll fix that later. Yeah, saturate's fucking stupid. Fuck saturate. I'm just going to clamp it myself. It's dumb as fuck. I think you can even clamp a vec3 with floats, so it literally doesn't matter that I might not do it correctly sometimes. Okay. So this is like a vec3 final scattering and a float final transmittance. And now you return these, and then it does something with these. This. Which just gives you back basically a vec4, so it's kind of really stupid. Result. Vec4. Okay. I know scattering times cloud exposure. What the fuck is this? 0.2? 2.0. Just makes it... okay, whatever. So there you go, final scattering, blah, blah, blah. Now alpha. Result alpha. 1.0 minus final transmittance. Return your result. So I'm doing the square root though. That was necessary. Whatever. Can I run it? Oh, definitely not, because that. Got to fix some errors. Whoops. That's definitely not the only error. Get light energy is not a function. So what is it called? It's not get light energy. Oh, it is. It's just down here. So just these two need to go up, I think. Who would have thought the fog would become this complicated? Because I actually sure as fuck did not. Current, okay. Current is what? Inside the scattering method? There's a lot of current. Oh, current is the sample. So when you call get light energy, yeah, you have to give it the sample. Alright, you have to give it a position. Okay, so this is a bit broken, right? But that's the only thing that uses it, so I can keep it as a position. Does it really have to be a position? Let's see. Yes, this guy does want a position. Okay, that's fair then. Fair. So this is your actual position at this point in time, which I guess I will just recalculate. Do I really want to recalculate it? I could have a vec3 sample position and a vec3 sample. I don't know if that's better or worse. And then this would be this and swap that out. Okay. Maybe better, I don't know, man. So sample position gets updated to this, and then sample gets updated using sample position. So there we go, it stays all the same. Good. And now, when I get light energy, I can do sample position instead. No additional calculations, but more assigns, maybe not. Mu. Yeah, mu is a thing that I don't understand. Okay, this is mu. Mu is the dot of the camera. Oh, this gives you, by the way, the actual direction of the camera. So it's the dot of the actual camera direction and the actual light direction. Sure. Can do that. If I'm getting, I want this to be a varying value, I think then, not per fragment. Per fragment is extremely stupid. Out back through the camera, dear. I wasn't planning on streaming this long today. It always happens, man. The inverse view times vec4 0 0 negative 1 0. Yeah, and I don't think it has to be normalized. Pretty sure. But you know what? I'll do it anyways. Doesn't matter. It has like four vectors in this entire thing. Okay, light direction I do have because that's here. Shadow light forward. Okay, there's my mu value. Got it. the minutes. Too few parameters. Okay, so this, yeah, this is what I have not yet updated, right? Because it needs a starting surface distance. So the starting surface distance is sample length. No, it's progress length. And then this progress length has to happen last. Because we're still in this fragment up to this point. So that's the starting surface distance. It's not perfect, but it is something that makes sense. Oh, check 4. You're right. So actually, that's what it should be, because just having the blend mode stuff, it should take care of that. We'll see. It's basically white anyways, I think. What's gonna happen? Okay. It's like black on the edges. And it has a lot of banding and stuff. Interesting. Why is it black on the edges? So it has to do with final scattering, which is the accumulated scattering, okay, basically, there's one thing I guessed at. Which was the sample length. So this should be not that hard to fix. It's just one of two things have to change. The extinction multiplier, or what was the other one? Cloud exposure. Accumulated scattering and cloud. Okay, so accumulated scattering is just totally ending up to not be right. I think one part of the problem is actually, I think it's assuming my blend function is something it's not, because no matter what, it should not be. How do I word it? It should not be black, I guess. Because yeah, the scattering has to do with the transmittance, and the transmittance is directly correlated to the alpha, so I'm just very skeptical of this whole thing. It's basically, in some way, multiplying the color by the alpha through this whole process, I think. What is this extinction multiplier? Maybe I should just, before I do anything, try changing this to something. Like, I have no idea what this does. Okay, it's totally gone now. I don't know then. It was 0.8 before, I'm pretty sure. Let's try this. Okay, interesting. I mean, it's like definitely, well, it's more opaque now, actually, kind of. That's interesting. It doesn't look bad. It's just the colors are like super wrong. I don't know why. I might just straight up make the cloud white. With the cloud not being white, you should be able to get more of the sun color in it, but I don't think this makes any sense. I don't know what else to do. I really wish... Like, this is definitely doing basically the right thing. Okay, what I think I need to do, I'm going to start at 1, which is the cloud color. And as it adds this stuff, integral scatter. How did it become a Vec 3, I wonder? Oh, this is the luminance? Okay. So this, yeah, this is... I want to just track... I feel like it's already tracking it, but in a really fucking weird way. But I'm gonna track it myself. I'll just call it total. So luminance, I think, is what I want to respect, which is used in the integral scatter value. See, what the fuck could possibly be the purpose of this? Fog strength times this whole thing over fog strength. Like, that can't be real. That can't be real. Hang on. Extinction times this whole thing over extinction. I'm not crazy, right? That does literally nothing, right? Does actually nothing. Huh? I'm gonna guess you don't want to divide it. Oh man, I'm just guessing shit now. So the integral scatter, I think, is what I want to respect. So I'm gonna add this up, and at the end of the whole process, we say accumulated scattering divided by the total. So now I have something that's maybe normalized, and since everything is white, I think it should be white. I fucking hope. But probably not. Okay, kinda. It looks so bad. Some parts of it. I also feel like it's making me lag a lot more. 200, it is making me lag a lot more. Interesting. Wow, the banding is like incredibly bad. Interesting. I can't tell what the light scattering is doing or not doing. I think then I gave this code a shot. I think this code has a lot of stuff that I actually want. But for example, I do not fucking want a color. Definitely do not fucking want a color. So I'm gonna get rid of that. I am gonna use like a large amount of this code actually, but energy, is that a Vec 3? Okay, no, thank God. Minutes. My transmission. So that all makes sense to me. I might have to look over that code to be sure it actually makes sense, but you get your accumulated scattering. I guess I need that. I need that multiply also. That reduces the, basically reduces the alpha into the cloud, I'm pretty sure. You do not need this. This returns a single thing, and so the final result of this, actually, I guess is basically this, right? Kinda don't need any of this other stuff. Which then, that means I don't actually need accumulated scattering, which means I don't actually need this, and I don't actually need... Oh, luminance? Oh, but I want luminance. Okay, so I'll try it without that. This will speed it up a fuck ton. I think it's gonna look kinda similar to how I had it, maybe better. Oh wait, I didn't finish this. Like half these functions in this thing are not being used now that I commented out that one line. Returns a vec afloat to fog scattering. So you are a vec for 111 fog. We'll see how this goes. I think I need that square root back somewhere where I square rooted the entire result of the fog density. It still has that banding stuff you can see to the right, which it didn't used to have that. Interesting. But if you look past that, it looks like actually better fog, really. Like it's way too thick. There's a lot wrong with it. I don't know why there's a very hard cutoff right here in the middle. But the quality of the fog, for some reason, it just feels like it's actually on the map. I don't know. I just need to get rid of that banding, which I don't know why that's happening, actually. It might have to do with the extinction multiplier, but it could also have to do with transmittance? I don't know. So I wonder what happens if I just say, so this is like some curve function for some reason or another. I should actually be allowed to do this, and it should at least look like something that is fog. Although, also, it really should be fog strength times sample length, since sample length is the scale of the whole thing. I just want to get rid of the banding. Oh my god. Okay, well now I can see why there's banding. Okay, so actually, this is very helpful. What the fuck? Does that really affect it that much? That's all I did, is it not? Wait, that doesn't make any sense. What all did I do? Wait, what? That's all I did. Let me try adding this back to see what happens. It's just totally opaque now, I guess. Okay, so... Interesting. This is just a much better depth, like, opacity accumulation function, but I can still actually do this. This is allowed. It's just... Oh, that's why. It ties into this. Okay, so... I don't want to change too much. I'm trying to change the same lines of code that I want to put back in a second. So just add this. And actually just return that. This might still be too intense. Maybe not. Oh my god, what the fuck? Oh, wait, I know oh! I think I know part of the problem. Maybe. It is maybe when I sample the fog density. Let's see. This. Where is it? What? That's not sample fog density. This. Surface nearness alpha of SDF to distance. This is fucking it all up, I think. In some way. I'm actually not sure how. SDF times UFOG, SDF unit. So that's times 3. Probably. Guess I can check. I'm almost certain it's times 3. I guess we'll check. Okay, so continuing, I'll check that as I go. So this will return, it'll basically make it happen 3 times faster. It's just a matter of, yeah, 0 is on the edge, so that'll be 0 at the edge, and it'll go to 1 as you go inside the fog, inside the SDF. So that is the distance. Okay, so that's valid. The only thing that I can maybe change. Let's try this first before I do too much. Did I even change anything though? Oh no. It says U fog SDF unit 0. Okay, okay, I was wrong. It is 0. If it's a mountain map, you do this, you assign it to the SDF unit, you serialize it. This is not really fat image, it's fat data. It should be called fat data. So... then it loads it, and it creates the SDF unit, creates the data, returns the data, serializes it, then loads it and does stuff. Why does that not work? I guess I can check it here. So this is a big part of the problem, why it was banding. It was actually sampling the SDF edge opacity, like transition as a flat clamp, flat step 0 to 1. Oh, wait, okay, now it's fine. Now it's 2.9. It just wasn't loaded yet. I'm just stupid. So yeah, it's like 3. Okay. I want to go delete the fat image though before I forget, because it's a fat data now. Okay. So that's not the problem. So the thing I just changed to cause it to do this, don't remember. I added the transmittance, I guess. What if I divide by 20? I mean, my whole screen shouldn't be white no matter what. Some math is wrong somewhere, right? Probably. Okay, well. Actually, I do see fog, which is surprising. Maybe whatever that issue was, I fixed it. I think it's almost time to end stream. I'm getting confused. I need to take a break. Okay, everything is white. Not good. I do see fog though, so I don't know what the fuck is happening. What is happening is, I think I know. I think I know. Oh, is it this? That's actually not what I thought. I thought it had to do with this add 0.001 thing, and how I'm clamping the edge of the alpha is probably always white, but this actually, if I'm doing it the other way now, right, it would be... This is how I'm doing it all. Put it on the same line. I would accumulate the transmittance. It's now additive instead of multiplicative. So that'll do something. Yeah, there we go. Okay, I still see extreme banding. That extreme banding... maybe has to do with this new function. What the fuck is it? This guy. So I'm gonna return the clamp of this over 3. STF nearness alpha, so it's a new function. Okay, let's try that out. Damn it, the banding is still there. It's kind of a cool effect, but it also looks actually kind of fucking cool. Maybe you could make that look good. It's like way too intense, but it's a start of something maybe, but let's see. Fog density. I'm not sure what else to do. I don't think it has to do with this. The surface distances, like this never even happens anymore. Light density, light energy. It's commented out. So the only thing is this, which is progress length, which that's fine. Well, this doesn't matter, but technically this should be multiplied by sample length right here. That's the actual fog strength. Oh, it's this, isn't it? Because the transmission works in another way. No. This right here, in fact, actually, I can just flip this around so I can keep doing the same thing where I have comments I want back on the same line. If it's greater than or equal to 0.99, it becomes 1.0 and breaks out. So if it's totally opaque, god damn it. Yeah, I do need to stop streaming. I'm brain dead, I think. Oh, the banding is still there though, but the fog does look more smooth. The banding is definitely still there. I wonder if it just has always been there and I didn't notice maybe. The banding is like nowhere else, so that might be a bad spot with like in terms of how the math works out and stuff. There, I do definitely see like some banding though. I can see over here. I mean, it looks okay. I feel like the fact that you can see this intersecting the wall or something means this function is not good. When you get the fog density. I don't want to do too much to this, because I don't think this is the problem. Well, yeah, that banding's not going away. Thanks for the follow. Yeah, so that made it a lot worse, for sure. Okay. I think I want to do... I'll do the same thing. I'm gonna just Return max of negative fog and 0 times... Let's not even do fog density. Let's just do that. I just want to get rid of the banding, and then I'm going to add stuff back. Like, if this doesn't get rid of the banding, I'm lost. Banding is still there. Holy shit. Okay, the other thought I had of what could be causing this banding is when it doesn't find the skip sample length is 4.0. Yeah, so like I said, it might just be bad math. That entire section might be like less than a 2.0 distance, and it's... And that would be... Okay, so if this fixes it... Okay, it does not. Bro. It's like this section. Oh. That looks to me like bad math, but I don't know how that's possible. I see banding up in the top right also. Okay. So, but that math I would only think to attribute to one of these two functions, so what the fuck? What if I do... What if I make it like incredibly accurate just to debug it? Oh wait, I did the wrong one. Oh, is that why I didn't see any update? Uh-oh. My bad. I will still make it incredibly accurate though. I'm gonna make it like something like 10 to 40 times more accurate. So goodbye FPS. Banding gone. 75 FPS. If I add back 0.5 and I keep this as 0.1, that's what I meant to change in the other function, but I changed the light scattering method accidentally. Does that fix it? Because that would be a skip. That's like an unlucky math inaccuracy issue. Okay, that does fix it. But so, here's the thing, right? That's unlucky. So when I add this back, the banding comes back. That's unlucky, but this should be fixable through the SDF surface nearness function. Because, I mean, I think, okay, the banding is back. Okay, so when you sample the fog density, you give it the progress length. That doesn't matter. When you sample the fog density, you get the actual SDF value and then SDF nearness alpha of negative fog. Okay, so I feel like if I return this stuff, I'll do it one at a time. I think this guy should work. So at 0, which is the boundary of the SDF, this returns 0. I mean, it's that simple, right? And this multiplies this by 3, and this divides by 3 again, so whatever. And might as well just try to get rid of that. Let's see what happens. I feel like this should fucking fix the banding. If I can fix the banding, I can add back the nice looking fog. Did I do something wrong? Return. Whoops. Banding not gone. I think it is, right, though, to multiply by U SDF unit. Is that what I called it? Fuck, it's not what I called it. U fog SDF unit. and then divided by 3. But also, I think I might want to do like -1. If I do, so the theory here is the ray is clipping the edge of the SDF, but when you're not inside an SDF, the ray is moving fast. Okay, so -1 made all the fog go away. Noted. I can maybe do it like this. That might work. So this makes the edge happen faster, and then I shift it by -1. The other thing I could do, if I also want to optimize it even more, I could actually... Okay, banding is there, but it's like... I don't know what to do about that. I would expect to see more banding in places where it goes over the edge. Yeah, like there's more banding right there. Is that really the expected result here? Is something going wrong? I really feel like I just messed something up. Oh, maybe I did. No, wait. Is this what I messed up? This is the actual SDF value, and this is with the nearness thing. That could have messed it up. Let's try this one more time. What I was saying though, I could ray step based on the SDF value. I can't tell if the banding is gone because the fog is so light now. I can't actually see anything. So, I mean, I can add back surface alpha. I'm pretty sure at least surface alpha is not the issue. Right, so it's kind of the same code now, except this is different. So this guy, I want to maybe do like 0.2 if I do anything at all. And then I could also, oh, that is actually a lot smarter. I can already do that. Yeah, that would actually fix the problem just entirely. Okay, so here's banding back. Let me actually just get rid of this entirely. So I'll make the banding even worse. Let's look at it. And what I'm going to do is when you're totally outside of an SDF, it's white. It is 1.0. So when it's 1.0 is when I will skip. Or actually, I can do even better. But should I? We'll see. So inside. So this gives you the sample fog density. I do want this to be able to return this is so fucked. So this is like an absolute SDF value, and this is an absolute distance. That's what has to happen here. Okay. Good. The surface nearness SDF is stupid. It's basically just making the SDF a exponent. And so, yeah, I'm returning negative fog times this stuff, which is surface alpha. Surface alpha is fair, though. Surface alpha is fair. Plus 0.0001, whatever. It actually is not even needed now. It's okay. So this can become negative. Negative meaning it's inside. Yeah, negative meaning, or how do I word it? Negative meaning it's totally outside of any visible fog. Okay, so now you have your fog strength, and so if it's greater than 1, otherwise what I can do is you say I'm doing this for now. If fog strength is less than or equal to negative 0.1, I think that's fair to do. You skip by this much, otherwise you skip by this much again. So I just don't know how surface alpha is going to play into this. Yeah, we'll see. So now, as it approaches the SDF, it should slow down its stepping to get an accurate step, and then when it's out of it, it speeds up again. Damn it. This should be like really fucking restrictive though, man. And if I do this, doesn't it get rid of the issue? Oh wait, it's actually adding negative fog value though now, by the way. Doesn't get rid of the issue. Wait, what? I got rid of the issue at one point by doing that. But it should not be allowed to add negative fog value. I didn't think about that. That's all. Okay, what if I just do this? Try this again. I am so confused. Basically don't need fog here, by the way. That's not how it works. If my step size is half, now what happens? There has to just be bad math going on somehow. I mean, you can still see it. I really feel like it's using a skip sample step. This never gets called. Oh, I edited the wrong function again. Okay, this function's gonna get commented out. I've done that twice now. Alright, so maybe it is still easy to fix, so... That's why I was so confused, because it didn't make any sense. So if you're actually at this value, then you add this. Otherwise, you continue stamping. What is it? Stamping? What is it? Skipping? Skipping, stepping slowly. Okay, fine. You can come back. Okay, I just won't do it again. Man. There we go. It's gone. Thank fucking God. Okay, so now I can add back all this stuff. So I don't need an SDF alpha. That's not really a thing. But I could just calculate it from fog and it would be the same function basically. It's just a matter of how quickly do I want the fog to fade. And no clamping. Well, I can clamp it. No, I can. Yes, I can clamp it to -1 and 1. No. Yeah, this is probably fine. Negative fog times surface alpha plus 0.01. Yeah, I'm getting rid of this one. It can stay like this, basically. So the other thing I wanted to try, because I'm curious here, let me bring this back. Did I already change this? Yeah, this should go back to 0.5. When all this is happening, this can totally happen. And then add skip sample length. I want to try scaling this. So skip strength. There's not much reason to do this, but it's just negative fog strength and clamp or min that and 1. So here's the delta of it times this plus sample length. Okay. So the benefit of this, oh, and the reason you do this is because I can remove all this stuff. So when you're basically right up on the SDF, but technically outside of it, you're going to be basically moving at the sample length. When you're really far away from it, you'll be moving at the maximum, which is 4 times. So what I'm worried about is that it's going to make it jitter as I move. It does not. Looks good. Looks very good. Okay, the square root has to come back, but maybe I do that not now. Because, okay, I fixed this problem, right? And so I wanted to bring back all this stuff. Let me push what I have. I haven't pushed like all fucking day. Technically is working with lots of functions I'm not actually using, but look good. All you people lurking here, check out and Wishlist Fat Goblins on Steam so it doesn't flop when I release it in like 5 months. Okay, accumulated transmittance. So I bring back basically all this stuff that has to do with the accumulated transmittance getting multiplicatively more intense, which is this, negative fogs, exponential negative fog, that looks right. It's supposed to go here. And maybe that's it. And this starts at 1.0. So it starts at total visibility and then it gets multiplicatively less visible as you go on. Okay, let's see how that looks. Whoops. And then if this looks okay at all, I'm going to end my stream, but I am going to make it look better off stream. So, yeah. Oh my God. What did I do? Oh, because this is supposed to be 1.0 minus. And there's also still a bunch of, there's like a bunch of optimizations I could do for this. Like, technically right now it's sampling completely everything. I only have to sample I only have to sample these sections of the map. So I could just render this geometry and then do this shader on top of that geometry, for example. Okay, so this looks like shit. I don't know what's happening here. I don't know why all this stuff is totally transparent. Is this wrong? It's no... Oh, and then it goes to 0.0. That's why. Those were the sections of the map that were actually totally opaque. So it was forcibly setting it to be transparent accidentally and then breaking out of the loop. Okay. Here's this function again. Interesting. Yeah, the heart should be opaque. So the fog should affect the hearts actually, but the hearts are transparent at the moment. I want to make the fog move again. Where the fuck was that? That was in the sample fog density method. Actually, it should currently be moving. It looks to me like there's no time value getting passed in, but there is. The fog should be moving. Oh no. Why is it not moving? Oh, it's not, the density is not getting multiplied. Okay, so just multiply the fog density inside this part, that gets the 1.0 added. Oh shit. You know what that actually means then? I kind of need out variables because now I have to track both of these things. Because I have to have the raw SCF value for the sample stepping, and then I have to have these two values for the not sample stepping. Okay, how does this work? You say out, float, fog, out, float, density. So it's that easy, and then, oh, but this is taken, fog sample. Okay. Density, I don't have to multiply this by that anymore. The purpose of this multiplication was to make it so when you're inside an SDF, it's never actually 0, no matter what the other two values are. Is it void now? I don't know how this works. It's probably void. So you would say fog strength, fog density, and then okay, almost fucking done. Almost. That's the light one. I'm not making that mistake again. You can't trick me, myself. So now I have all this stuff, and then I sample this for like the STF values, right? And so this is what matters here. Oh my god, I did it again. I already did it again. This goes here. So before I do this, then I actually need to check if it looks good. Invalid operands multiply something. Oh, you're right. I should multiply that by fog density. That would make a lot more sense. So same with you, I'm sure, right? Well, it's supposed to be, even if it's not happening. This method's just like omega fucked, but whatever, I'm not even using it. If I use it, I'll go back and clean it. How is that incorrect? Expecting other things. Oh, because this has to be that. Okay. Okay. And so that sample on the edge still does look good. I can see it very slightly moving, but it looks good. Okay, now lastly, I take this and I just, in the transmittance value, multiply this by fog density. Okay, it is moving again. I do see some banding, but I think that has to do with maybe the surface alpha. But it's looking good. And yeah, you can see this edge like never goes away. So the SDF is too, how do I word it? It's like this should basically be divided by 3. This one, I don't know why it might actually need absolute distance. I don't think this ever needs absolute distance. Progress length. Yeah, that can never go negative. Why did I do that? Maybe because I was reusing that function at some point. So let's get rid of that absolute, and I could divide by 2 or something and make it... Okay. Here's something. There's a lot more I can do to it. It's still like obviously banding in some places. It's hard to say exactly why that might be. I think it's possible. I think like at the very least, I think I need multiple noise samples on this thing. And another issue is it actually just goes off the sides too much. So I don't know how I'm going to fix that. Like this one looks good. Oh, actually, so that's not that hard to fix. This one looks good. This one just... It's too high, though. The fog is too tall. And also, I have to do another layer of texture sampling where I, like, greatly... Uh-oh, I died. The fog went down with me. That was not good. I don't know why I did that. Oh, because it was clamping it? Oh, that's odd. I didn't really consider that. What was happening was when I jumped off, I have that method to clamp my camera to the fog. So if I go off, see the fog's coming with me. Because it's clamping all my coordinates in the shader. What the fuck? That looks so weird, man. There it is! What? Wait, has that been there the whole time? Am I... What? Oh. What the... I think... No, actually, I'm just like beyond confused. Okay, well that's another bug to fix. That's something interesting that's happening. That's the fog. It's like rendering it twice. It definitely has something to do with my math to project to the edges of the thing, for sure. So yeah, I need to remake my SDF meshes. I need to fix this banding right here. Let me write this down. It's starting to look good though. Like it doesn't look good, but I can do so much more with it. Fix volumetric fog. Convex meshes so it doesn't go down the sides of the, I don't know, things. It doesn't go down the sides. And then fix volumetric fog banding. I do not know why this one's happening. I still think actually it has to do with my surface distance. I probably just have to like do it. I'll try that one more thing. And then the other issue was fix the floating fogs in this guy. It might actually be stepping through these, which will lower my FPS, by the way. It might actually be doing that. The one other thing I'm going to try before I get off. This is a clamp of this guy over 2.0 or whatever. I'm going to try an exponent of this. But I don't know how this function works anymore. I want to do it real fast because I need to walk my dog. Minus 0.135, and then the entire thing. Ugh. Entire thing over 0.865. I don't know if this is how this is supposed to work. Okay, here's my function. Exponent negative thing, 0.135, 0.865. 0.135, 865. That's how it worked, right? Wait, no. This is this. I'm curious what this will do. This is gonna make it... Wait. 1.0 minus. So at a distance of 0, this is 0, and then it curves up towards 1 over like 2 or 4 something units. I might remove the banding. Did not really remove the banding, but I think it might look smoother. It's hard to say. The edges still look too hard to me. This could have that same function applied to it. I could take this whole thing, see what that does real quick. I just keep accidentally doing things. Did that remove the hardness of the edges? Nope. Okay, so I tried. That didn't really fix either of these two problems, so I'm gonna undo this and now try to fix them off stream. So here we go. I'm gonna commit it again. Decent fog. I'll fly through the level once and just take a look at it, and then tomorrow, not tomorrow, I don't know, whenever I stream next, Monday or Tuesday, I will show the final result of the fog. And actually I may not be streaming next week because I have to work on my video for Tokyo Game Show. So here's the final version of the fog right now. Definitely not done. There's so much that has to be fixed with this. Cool. Looks pretty good. Oh, look how bad this part of the map looks. Okay, anyways,